Dr. Muhammad, 5 minutes. 5 minutes left. 5 minutes. Thank you very much, Dr. Muhammad, for the nice presentation. Audience, the floor is yours, so if you have questions, please proceed. Any question? Okay, Dr. Muhammad, so I have just one question on, you functionalized the titanium dioxide with silver, and you observed enhancement of the removal, right? Any idea about the reason? What is the mechanism of this enhancement? Okay. Thank you very much, Dr. Muhammad. Thank you. Thank you. Assalamu alaikum. Dr. Muhammad Al-Waqfi. وين presented؟ ما في حل. ما راح. Assalamu alaikum and good afternoon. It's my pleasure to introduce Dr. Muhammad Al-Waqfi. Dr. Muhammad has done his PhD in chemical engineering in Canada. After that, he took some administrative position, big roles in some institutes, like for example, the director of Jordan Armed Forces, plus other key positions. Currently, he's working as assistant professor in Fire and Safety Engineering Department, Prince Al Hussein bin Abdullah Al Thani Academy of Civil Protection, Al Balqa Applied University. Dr. Muhammad, the floor is yours.
Thank you very much. Thank you. محاضرة اليوم راح تكون بعنوان an iron rotating disk for the elimination of hexavalent chromium ion from industrial waste waters, putting it to work. طبعا الخلفية الريسيرش انه عادة البروسيسز اللي مستخدمة للريدكشن للهكسافالنت كروميوم، طبعا الهكسافالنت كروميوم زي ما بتعرفوا وللي ما بيعرف انه بيكون عادة ان سوليوشن، فبصير له ريدكشن بداية لسي ار بلس 3 اوكي، وبعدين بيصير له بريسيبيتيشن على شكل هيدروكسيد. الموست كومن يوزد ميثودز اللي هو الصوديوم ميتابايسلفايت، نعمل ريدكشن بالصوديوم ميتابايسلفايت بالاضافة للايرون. طبعا البروسيسز اللي اوريدي موجوده واللي مستخدمه موجوده بالليترشر اللي هو عباره عن ممكن فلويدايزد بيدز او على شكل جرانيولز او على شكل وول اوكي. طبعا البروسيسز اللي زي هيك بكون في عرضه كثير انه يصير فيه لها كلوجينج، زائد انه في ترسبات على سطح الحديد بحيث انه بيعمل تيرمينيشن لا التفاعل ما بين السي ار بلس 6 او لا الريموفال اوف سي ار بلس 6. فارتأيت انه ممكن احنا نستخدم ايرون روتيتنج ديسك لانه من نتيجه الحركه نتيجه الموشن فبيمنع او بيقلل كثير، بيعمل مينيمايزيشن للترسبات اللي ممكن تترسب على سطح الايرون، فبضل في عندنا اكتف سايتس حتى انه تو بروسيد وذ ذا رياكشن. كروميوم ايون، الهكسافيلنت كروميوم ايون طبعا هو ايون سام جدا، مؤذي وهارمفول للهيومنز للانيمالز وللانفايرمنت. طبعا الصناعات اللي ممكن يكون بالانفلونس بتاعتها موجود سي ار بلس 6 ايونز، مثل صناعه الدباغه والميتال بليتنج شوبس. Elimination of CR+6 is usually achieved via its reduction by using metabisulfite زي ما حكينا او الفيرس ايونز، او استخدام الزيرو فيلنت ايرون او زيرو فيلنت ايرون. طبعا في restrictions على البيرميسبل ليفلز اللي ممكن احنا نعملها discharge للانفايرمنت او انها تكون موجوده بالدرينكينج ووتر. طبعا very strict restrictions بما في المواصفات الأردنية النافذة في يعني الحدود المسموح فيها قليلة جدا، فعشان هيك هذا الكلام بيعكس خطورة الأيون والضرورة إنه حتى نتعامل معه ونشيله من الإنفلونس بالنسبة للإندستريز. The current article aims at identification of the optimum process conditions controlling and determining the efficiency of CR+6 removal by utilizing rotating iron disk through examining the reduction kinetics. طبعا الاوبجكتيف بالنسبه للدراسه اللي احنا عملناها اللي هو نطلع بكونديشنز اوبتيمم كونديشنز. نعم اوكي، نطلع باوبتيمم كونديشنز بالنسبه للظروف المثاليه حتى يكون عندنا التفاعل او نحصل على ماكسيمم ريموفال افشنسي بالنسبه ل CR+6. الاكسبيرمنتال سيت اب اللي استخدمناه هو عباره عن بنش سكيل سيت اب، يعني ما وصلناش للبايلوت سكيل، بس مجرد تجارب في المختبر. طبعا عملنا عده تجارب في المختبر. السيت اب بسيط جدا، هو عباره عن بيكر بنخلي فيه السامبل. طبعا السامبل اللي بتحتوي على CR+6 احنا اخذناها من الواقع من البليتنج شوب، دايكروميت ديبنج تانك اسمه، بيكون فيه موجود CR+6 بالمحلول. اوكي، فالسيت اب بتكون من روتيتنج ديسك، والروتيتنج ديسك هذا كونكتد فيا شافت ل فاريبل سبيد موتور. طبعا فاريبل سبيد موتور حتى يعطينا حريه انه احنا نقدر نزيد الار بي ام، اوكي، ونتحكم بالار بي ام. طبعا هو الهدف من الروتيتنج ديسك زي ما حكينا انه حتى نعمل مينيمايزيشن للترسبات اللي بتحصل خلال التفاعلات الكيميائيه ما بين الزيرو فيلنت ايرون والفيرس ايونز بالاضافه لهيك والسي ار بلس 6. فنتيجه الموشن بتساعد او بتمنع يصير في بريسيبيتيتس على الايرون سيرفيس. لا هذا شايف هاي القديمه، هاي القديمه انا حطيت برزنتيشن جديد وحكيت لهم يعملوا له ريبليسمنت وجيت الصبح عليهم للاسف. طيب على كل حال طيب خلال الليتراتشر واضح انه الريدكشن بروسيس هو عباره عن سودو كاينتيك او كان بي described by a pseudo kinetic model. اوكي، pseudo kinetic model بيعني ليش رحنا هيك؟ لا مش اشكال، انه لو ممكن بمشي حالي لو تركنا. انا اليوم الصبح بعثت لهم امبارح ايميل بالليل، واليوم الصبح جيت وعدلنا اني حكيت له شيل القديم. بس القديم شفنا احنا اعطينا هذا. لو خليته كان مشيت حالي. اوكي لا هي نفسها، مش اشكال. اذا زي ما حكينا انه حسب الليترشر الرياكشن او reduction process can be described by pseudo first order reaction kinetics. شو بيعني؟ بيعني if we plot أو ليش برجعش؟ ليش برجعش؟ ليش برجعش؟ مش راجع، اشتغلش. طب من عندك تقدر تحركه؟ روح سلايد للخلف، لا سلايد للخلف اذا سمحت، للخلف. لا كمان ارجع، رجوع كمان. اوكي. طبعا شو بيعني سودو فيرست اوردر كاينetics؟ انه الدي سي ار، اوكي، الدي سي ار دي تي او الديسابيرنس ريت، الرياكشن ريت للريدكشن بروسيس can be described by this differential equation which is dCr dt يساوي minus k cr plus 6. simple integration we end up with this simple equation اللي هو minus ln c over c naught يساوي kt. okay. طبعا if we plot this equation we should get straight lines, okay, and those straight lines they intersect أو they intersect with the origin, okay. طبعا لما نطلع على الفيتنج results بالنسبة للstraight lines بنلاحظ إنه الريزلتس الار سكويرد very high، بيعني إنه الداتا اللي we obtained بالنسبة للإكسبيرمنتس اللي إحنا عملناهم they obey الفيرست اوردر كاينetics. طبعا السلوب بالنسبة لللاين هو عبارة عن الريت كونستانت، الرياكشن ريت كونستانت. إذا بنطلع على قيم الريت كونستانت بنلاحظ إنه as we increase ال RPM، اوكي، أو as طبعا هاي على كونستانت، اوكي، سي initial 100 ppm pH 1.5 الراديوس 4.75 اللي هو rotating disk. as we increase ال RPM، اوكي، the reaction rate 3 minutes، اوكي، الرياكشن ريت increases up to a point بعدين بتصير ثابت الرياكشن ريت. هذا بيعني انه احنا بنوصل مرحله انه ببطل الرياكشن يصير ماس ترانسفير كنترول، بصير كاينتيك رياكشن كنترول. if we plot الرياكشن ريت in different way using this equation، ال K يساوي 0.C62 D223 V to power minus 1 over 6 times omega اللي هو الانgular velocity to power half. okay, we get this curve which ليش هيك؟ we get this curve اللي بيثبت لنا انه على الهاي اللي بيثبت لنا انه على هاي روتيشن ريتس عندنا الريت ديتيرمينينج ستيب بتصير رياكشن كنترولينج كاينetics باي كاينetics نوت الماس ترانسفير. طبعا هاي different plotting of the results، different modes of plotting. طبعا خليني اروح للنتيجه الاهم بما انه خلصنا الوقت تقريبا. الكونكلوجن انه الايرون روتيتنج ديسك ممكن يكون عندنا فيابل اوبشن انه نعمل تريتمنت للهكسافالنت كروميوم، اوكي، بطريقه بسيطه جدا وبدون ما تكون مكلفه وتكون قابله للتطبيق بالنسبه للصناعات الاردنيه الصغيره. بالاضافه انه زي ما حكينا انه الريموفال افشنسيز بتكون عاليه جدا، لكن وي هاف تو تيك انتو اكاونت انه افتر يعني above 700 RPM بصير عندنا ماس كاينتيك كنترول. فاذا المفروض انه وي شودنت اوبريت above 700 RPM لانه it makes no difference. لازم يكون الماكسيمم بالنسبه للاوبتيمم RPM اللي هو 700 RPM. وبشكركم على الاصغاء وانا اسف. تفضل. يعني انا حاولت جهدي.
Thank you very much, Dr. Al-Waqfi, for the nice presentation. Now, for the audience, if you have any question, please ask Dr. Al-Waqfi. Any question? Any question for Dr.
Hello, Vladimir, are you with us? Hello.
Okay, thank you very much, Dr. Waqfi.
Vladimir? You started before your time. Now you can start for 5 minutes, please. To get 5 to 7 minutes. Very, very fast. Huh?
From the first
اللغة الإنجليزية.
متى وقته هذا؟
أوكي. هلا وقت. 12:10. بوستر.
yes, from the first page.
أوكي.
Yes. Okay.
دكتور لو تخلص.
مش خلص
هذا هو أيوه.
هلا هو نبلش؟
هو خلص.
هذا نبلش فون.
أيوه.
كل 5 دقائق واحد لنفسه.
بس 5 minutes. Please continue, Vladimir.
In this paper, this is the result of experimental studies for depleted uranium hexafluoride safe evaporation from containers. This process based on method heating of materials through heat absorbing agents. They were
هلا بكبل.
the next day was
احنا الابهاب نقدر من هون نعمل نشيله كمان شوي. Thank you, Dr. Vladimir. We are now we will finish this presentation and start with the second because we have only very limited time. علا موجودة معنا علا؟ علا؟ محمد السيد؟ مش موجودة. وين تبعين العرض اللي بدنا؟ هي ما شو بالله؟ سوري بي دقيقة والله. هنا شو اسمها بالله؟ ها؟ هنا محمود. مين هاي كمان؟ رائد ياسين. رائد خالد ياسين. يلا تفضل يا دكتور رائد. خليه يعمل شيرينج والله.
Shared. You can see my screen, huh?
Yes, we are with you. Please, you have 7 minutes only.
Inshallah, we'll finish on time.
Yeah, okay.
Okay, good afternoon, gentlemen. This topic for today will be related to the contractors and industrial sustainability, and we will just go very quick and brief to try our level best to finalize this presentation on time, and so you can get the benefit and the fruit of contractor management. And this already based on our experience in a company which is related to Ma'aden, Wadi Shamal and Torayb city in the north of Saudi Arabia. And let us focus on the contractor management. The contractor management is key in any organization. And there is several factors will impact the performance of the organization from the contractor's management. So first, the usually is the number of the contractors manpower is high and higher than the direct hire or the global contractors in any organization. So most of the companies, they are hiring contractors to do a short-term business with those contractors so they can finalize it. And based on that, there is several factors will affect the safety performance and the sustainability of the organization. The second one, which is having an employees with different background, different nationalities, different experience. So this one also affecting rapidly the safety performance inside the organization. As well, in some country, they have different language. Example, in Saudi Arabia here, we are facing the different languages which our employees, they are talking about it. Example, English language, Arabic, and Tagalog, Indian, Urdu, etc. There is several language they are using. So when you are trying to communicate with people, you will face a difficulty, especially with low or poor educational employees, especially the workers and the labor. The last point is the turnover of the employees. So those contractors, they will not let their employees working for a long time because they are dependent on the needs. So those contractors, they hire those employees for short time period, and this will affect the safety performance because the safety culture will be impacted due to this reason. So I'll move to the second slide. These are the main steps in evaluating the contractors. So the first one is working analysis and how we prepare the scope for. The scope for related to those contractors is very important, and this will give us an indication based on what we will identify the type of contractor and the number of manpowers, the expected manpowers, the duration, etc. Then to the contractor bidding and evaluation through the procurement, and this is also another step and another milestone. It will be impacted financially because those employees or those contractors will be evaluated financially and technically and as well from safety point of view. The third point will be the contractor selection and kick-off meeting with those contractors to select the manpowers, and based on what we select the competent people so they can run the business. And after that, we'll go to the orientation and training for those employees who will be mobilized to the site. Then the number 5, which is the execution of the job, and with a close management to the work, and make sure those contractors, they apply with the requirement. And after that, continuous performance evaluation, post-contract evaluation, and this is a continuous process to make sure those contractors, they are running the business and make sure the sustainability of the production of the organization. As you can see here, this is some of the statistics which we already gathered during the last 5 years across 46 companies who are working with Ma'aden, with total manpower almost reached to 2,800 right now. Before, during 2018, it was reached to 20,000 employees working from the contractor side. As you can see, this is related to the total recordable injuries, which include the fatality, lost time injuries, restricted duty, and medical treatment cases. And you can see here in this bar chart, you will see there in 2020, we had a fatality. And those recordable injuries give us an indication, those contractors, they will lead to having a fatality, but because of management system failure during this monitoring process, we failed to capture that fatality and to prevent it.
Dr. Rad, you have 1 minute.
And this one, you can see, yes. 1 minute, okay. Let me go briefly to this slide. This is showing to you the head count of the employees and based on the category 2 and category 1. And in category 2, this is the critical. You can see there 2,400 employees, and the number of companies, it's almost 46 companies. And this is the total number of safety officers who are managing the contract side organization, which is almost 105. In conclusion, let me conclude this presentation. If the contractors in very well close monitoring to those contractors with best or better improvement to evaluate their performance, that means we'll make sure the sustainability of the production inside the organization. That's all from myself. Thank you.
Thank you very much, Dr. Riyad. Dr. Raid, sorry.
Most welcome.
Dr. Ahmed Rafiq Musa. Ahmed Musa.
مهندس ان شاء الله استاذ دكتور جاهز محاضرتك؟ عندك السلسله هو بس حاول
دكتور جوانا كوجاوا. دكتور جوانا. دكتور جوانا.
دكتور نور الجمال موجودة؟ تفضلي. مهندسة ولا دكتورة؟ تفضلي.
مين؟ Assalamu alaikum and good afternoon. I'm pleased to introduce Dr. Noor Al-Jamal. Dr. Noor has completed his her first PhD degree from Hungary in environmental and chemical industries. She currently pursuing another PhD, so second PhD, mashallah, on MOFs and zeolites applications for environmental remediation of some problems, environmental problems. So, Dr. Noor, the floor is yours.
Okay, thank you. Yeah. Okay, I will be fast as much as I can. Assalamu alaikum. My presentation will be focused on the sulfonated MEL 101 as metal organic framework as catalyst to be used as microwave responsive catalyst for sugar conversion into platform chemicals, specifically hydroxymethylfurfural. As we know that the world suffered from depletion of fossil fuels, so which triggered the global attention in finding renewable resources to be used as a fuel. Among these renewable resources is biomass feedstock. Agricultural waste, food waste can be converted into platform chemicals and through several processes like gas, or liquid fermentation, acid hydrolysis, gasification, or dehydration process to produce fuels or fuel additives or chemicals that can be converted to other material. I will be focused on furfural because this material can be transferred into or can be used in several chemical industries. So hydroxymethylfurfural, it has limited application, but it can be converted to several things, as I mentioned, it can be used as a fuel or in plastic industry, where we can get this material from cellulose or hemicellulose or lignin, because it's rich in sugar. So via some modification or degradation processes, we can have sugars. The problem of this process, it's the selectivity of this compound, hydroxymethylfurfural, is very selectivity is very low. So I tried to use potential catalyst for this reaction to increase the selectivity into hydroxymethylfurfural, along with a new technology. I tried to use a new reactor, a microwave reactor. By these two things, I tried to increase the selectivity and stability of this intermediate product. So the goal of my work is to investigate and to find which kind of MOFs can be used for this kind of reaction. And I want to also investigate is microwave can be used to intensify the biomass conversion. I also try to quantify the microwave effect on the reaction itself via Arrhenius or thermodynamic studies. So brief outline for my work. I will give brief introduction about the metal organic framework and microwave. Then I will show my results, some kinetic modeling result, and final conclusion. So the material that I used, it's called metal organic framework. It has infinite chemistry because we have hundreds or thousands of metal clusters can be joined with linkers, organic linkers, and we can functionalize these linkers with many functional groups to have literally infinite number or millions of a framework. And thus, there is many application recognized for these materials. Here I want to tell that these materials was invented by Omar Yaghi, his Jordanian American chemist, and really he made a revolution in this science. So many times, revolution are not recognized until they pass, and we are truly in the middle of revolution in material science, as we can use this material to solve our problems in environmental and energy. Here, I just want you to consider yourself as molecules floating, floating between this or pores of this molecule. This is the structure of metal organic framework. So this material has high surface area. It can reach more than 10,000 square meters per gram. So here, I want to show how we synthesize this kind of material. Here we are talking about what we call solvothermal synthesis or self-assembly. We just add the organic linker and the metal cluster together, and we program them to find each other in a specific fashion, so depending on the desired application. So here we are not talking about centimeter or micrometer regime, but we talk about nano regime. Some of the MOFs that I synthesized is UIO66. This MOF has high acidity. Other MOFs, I used several MOFs, functionalized one, and most of these MOFs, I want to just show the surface area analysis, just to show how incredible the potential surface area of each kind of MOF. It's between 3,000 to 1,000 square meter per gram. And this slide shows a schematic diagram for my reaction. So we put everything in one pot fashion, the fructose and the solvent and the catalyst. We use microwave and conventional heating just for comparison, and then we analyze everything using HPLC. Here, I just want to show a small comparison between hot plate and microwave heating. In microwave heating, we could have what we call volumetric heating, or we can call direct volumetric heating, there is direct activation of molecules in the solution. So this material or the catalyst that I synthesized can be considered as microwave absorptive material because it has sulfur or it has some polar group that absorb microwave radiation, and by this coupling microwave with this active site can activate my reactant and can increase the selectivity of the desired product. This slide shows a brief mechanism for my reaction. So here we can see the sulfur group after activated or coupled with the microwave heating. Through 3 elimination steps, dehydration step, we can have from fructose the desired product hydroxymethylfurfural. We try to find a formula to understand the communication between the power of microwave and the reaction or the catalyst. So we found this formula which called efficiency coefficient. So and it was equal for the yield of the desired product over the power, time, and the volume of the reaction. It was found that the standard power mode was the best to have higher efficiency coefficient. So all the steps or parametric study was conducted using standard power mode, where the power varied between 100 to 150 watt. Here we show the result of catalyst screening, because we tested several MOFs. We found that MEL 1 of one family, like chromium and zirconium-based MOFs, have HMF, but with the ZEFs and MOF5, we can see that there is no hydroxymethylfurfural, because through that catalyst, some other reaction was enhanced, but not the desired one. So for the next slide, I only used MEL 101, sulfonated MEL 101. Here also, I try to understand that the sulfur group, the communication between sulfur group and microwave. And it was clear that the sulfur group, because of the interaction with microwave radiation, there were 8.7-fold enhancement in the efficiency coefficient. We also tried to study the grafting rate of sulfur group in the parent MEL 101, and we found the best one, like 0.9 was the best one. Also, it's very important to study the solvent for the reaction to find the normal or the best solvent, the green solvent. We tried to test the green solvent like water and ethanol. We tried to test high boiling solvent and biphasing system. But we found that solvent with DMSO, oh my God, solvent with DMSO has the highest yield, because DMSO can, as we can see from this slide, DMSO can protect and act as shield to protect my HMF from rehydration to give me other side product like luvinic or formic acid. Perhaps the most important or benefit from microwave is the reduction of total reaction or synthesis time. So as we can see, by 5 or 10 minutes, we can have 90% yield. Can you imagine? With the microwave. So this slide also shows the difference between microwave and conventional heating. So to obtain at least 95% yield of HMF with conventional heating, I need at least 5 hours. But with microwave heating, it takes only 10 minutes. Here's some just comparison between microwave and conventional heating. We can see the microwave effect is very clear at less severe condition at 140 degrees. We have higher yield than conventional heating. Here I just want to show the slide how reaction temperature and concentration can change the product color due to caramelization or side product formation, which we call Homan. It's very complicated compound, and it's very difficult to quantify. For the kinetic study, we tried to find the reaction network, the simple reaction network. We make our assumption that the fructose dehydration is I am finishing. Fructose dehydration is first order reaction, and then we follow some regression analysis using Athena Visual Studio, and then as we can see, this is the concentration profile. Reaction rate through microwave was 0.8 second, but with conventional heating was only 0.1. So there is 0.8 enhancement in the reaction rate using microwave. We tried, by performing some kinetic study, we estimated entropy and the heat of enthalpy of microwave effect to understand the reaction. So as a conclusion remark, so really, indeed microwave has a good and effect on selectivity of hydroxymethylfurfural, and MOFs, highly acidic MOFs can be used for this reaction. Finally, I want to thank my professor from Ghent University and Wuhan University and Ghent University Global Campus in South Korea, Professor Yuri, Francis, and Professor Philip. Thank you.
Thank you very much, Dr. Noor. Audience, please, if you have questions, please proceed and ask Dr. Noor.
You used microwave to assist the dehydration of fructose, right? Okay, I think there is a relation between the microwave energy or the radiation and the temperature of the reaction. Did you inspect that?
Yes, for sure. We studied what we call T-effective. So we tried to study what we call T-effective temperature due to hot spot formation. Fructose has OH, it's polar group. It can absorb microwave and it creates hot spot. And we found that with this hot spot, local heating domain, there is 10 or 60 degree extra to the desired temperature. So we still investigating that, and this is what I'm focusing now in my study in Belgium on the kinetic study to quantify the microwave effect through temperature. And we just found that indeed microwave reactor beat Arrhenius equation. We cannot use Arrhenius equation to quantify, yeah, this is what we found. Thank you.
Any more questions? Okay, we have to move to the...
I have a question for you.
Okay, for sure.
So you used MOFs for this work, right?
Yes.
But MOFs quite expensive. So from economic point of view,
not all, yeah.
How you justify the
okay,
use
not
of
all
MOFs?
MOFs are expensive, and it's commercialized now. It start to be sold on large scale. So this MOFs we can use it not pure as it is. We can use it in composite material. So the idea is just to check if can help with the selectivity, but by the commercializing, pelletizing, trying to scale up the process, there is many solutions for that. And now they are using MOFs for hydrogen storage for some cars, and they really use it. Like there is a large scale of application of some MOFs. Some MOFs are really expensive, but like ZEFs for water remediation are very cheap. But as you said, some MOFs are really expensive due to the linkers, unless you want to start from the scratch, not to buy the, yeah.
How about stability of the material?
Yeah, so some MOFs it depends on the atmosphere or circumstances that you use. Some MOFs are not stable at water. Some MOFs are more stable, like UIO MIL 101 considered as Ropset MOF, and it can handle higher temperature and stable because we use dehydration reaction. There is some water molecule, and it's stable in this kind of condition. But this is what I meant with catalyst screening. So I eliminate the catalysts that are not stable, and I focused on the Ropset material that it can increase the selectivity of the desired product.
Thank you very much.
Thank you.
Thank you very much. Yeah, سؤال. يعني تأثير الميكروويف راديشن يعني ها؟
هلا لا it's I will just هلا احنا الميكروويف we used it at small scale. The problem of microwave, how can be used in large scale? So this one, it needs maybe another PhD to focus on that, because في nuclear power plant, it's used very far, or in protected area. بس هلا كيف انه يعملوه لارج سكيل، هاي بتضل الكيميكال انجينيرز. هلا انا بعتبر حالي مور كيمست ذان كيميكال انجينير، لانه رحت اكثر كيمياء. انا من وجهة نظري انه it needs more research to scale up the process, and for sure some risk assessment must be done in any process to be scaled, have to be scaled. شكرا.
Yeah. Now it's your turn. Okay. Come and shoot. Yeah, you should give her applause, huh? Okay, our next presenter is Dr. Joanna Kujua. Did I spell it right? She's a professor at Nicholas Copernicus University in Poland, working in the material and membrane science. The area of interest focuses on water and wastewater treatment, desalination design and production, new separation materials for advanced separation. The research accomplishes in the frame of cooperation between Polish University and German Jordanian University in Jordan. She will, the title of her talk will be Tools of Material Engineering for Designing Membrane Materials with Desired Features, right? So you have less than 20 minutes. Go ahead.
Thank you so much for this kind introduction. And yes, today it's my pleasure to present our recent data related to this work to design new materials for the separation materials that has been done in the cooperation between GJU and Nicolaus Copernicus University in Toruń, Poland. Talking about the material separation material to the different processes, we need to understand and define what type of properties, the features, we are able to control and to modify. So for sure, the properties like hydrophobicity, hydrophilicity, the roughness, the morphology of the structure, the physical chemistry, stability, all of these features we are able to control, and out of this we can tune or design the transport and separation. In our work, we focus on the PVDF polymer, the polyvinyl fluorine, due to its very interesting composition and high stability. And thanks to these properties, the PVDF found a lot of application in separation, bioseparation, and much more. However, more sophisticated applications are still limited due to the highly inert character of this material. So to change this material, the character to labile one, and to be easy to functionalize, it was necessary to modify. And based on the literature survey, we can find a lot of opportunities by physical mixing the polymer with other additives, inorganic particles, or ZIF, MOV, zeolites. However, we want to develop the material that will be stable during the separation process. So for that reason, the grafting was the most efficient to modify in a chemical way the material. And as a modifier, we select the chitosan. The chitosan, it's coming from the nature. It's available in the armor of the shrimps and crabs, and it's considered as a bio-waste. So this zero waste philosophy, it's really available everywhere. It found a lot of application. However, from the point of view of the chemistry, it's very important that have two type of functional groups, hydroxyl and amine. So it was able to modify in this chemical way. And to modify the material, we actually find the solution available in nature. So by the mimic of the structure of the beetle, desert beetle that have the highly hydrophobic surface of the armor with the hydrophilic knots, it's able to harvest the water from the fog and survive in very harsh condition of the desert. So by biomimicry of the surface, we develop the structure, just copy this natural available surface to have the hydrophobic surface of the PVDF with the hydrophilic islands, and to generate this surface. So the modification has been done by following steps. First, we activate it, so we solve the problem with the inert character by activation, modify the chitosan, and finally did the hybrid material. Of course, material has been characterized by different techniques, and finally apply in the separation for removal of hazardous volatile organic compounds and dehydration of the juice. So from the chemistry point of view, it looks in following way that this material was generated and proved one by one. So first the activation process was confirmed by FTIR technique that indeed these hydroxyl groups were generated efficiently. Then the chitosan was chemically modified, and in dactyloscopic region we could find the characteristic bands, and on the end this hybrid material was generated, and also this characteristic band proving that both modification went by a chemical way has been done. Different techniques like transmission electron microscopy confirm also this modification of chitosan, and of course such modification change a lot the properties, like thermal properties. So we actually improved the thermal properties from the pristine material to the modified one. The phase changes, as in the PVDF, it's important to follow these phases because they have different form, and by activation process we generated more hydrophobic alpha form. But to observe this more hydrophilic as for the hybrid was also a sign that the hydrophilic chitosan, these nodes, this island were generated. Of course, the morphology changed by the chitosan flakes were available on the surface as well as inside the whole porous structure. Of course, the roughness of the material changed a lot, and the hydrophobicity. But what was important, all of the material were hydrophobic, so were suitable for membrane distillation, were porous and hydrophobic, and we are able to use them. Thanks to introduction, this chitosan, the hydrophilic chitosan, we improved the transport of the water, as well as, and all of the material were really stable in longer time, the process. But not only water transport was improved, also the separation, and we can compare this pristine or activated with the modified, that indeed the improvement was much higher. And just to compare, the process separation index changed from 6 to above 90, so it's a big improvement. And this process separation index contains the separation and transport features in the same time. In case of the osmotic membrane distillation, so it was a process applied for the juice dehydration, and it should be stressed that this is process done at room temperature. So it's very important because we can dehydrate the juice, raw juice, and we are not losing these valuable properties like vitamins, antioxidant activity, and others, but we just can remove the water. So what was here very important, because of the chitosan and their hydrophilic character, it was possible to mitigate the fouling. And for the pristine material, really the material was very covered by this juice, by this layer. However, the functionalized material, this hybrid material, was practically clean after process, and we repeat this process a few times, and the same results was observed. The fouling was analyzed by different parameters, and we could see that indeed this normalized flux decline was the smallest for the hybrid. In case of flux recovery ratio, so the flux that should come back to the starting value was also very high for the hybrid membrane. The reversible flux decline that has been found related. Okay, so it was just to state, it was really the best for this modified membranes. So this was as a result of this modification by the bio-inspired surface. But in our work, not only this inspiration by the beetle desert we used in different work, just to in a short way present, we also copied the lotus leaf effect and rosa petal effect in the one single modification to modify the rare earth oxide that allow us to generate this fractal-like structure. So this can be applied as an additive to the membrane as modifier. And another work that also the solution was found in the nature. So we generate the hedgehog-like structure to use this single-wall carbon nanohorn. So it's quite new material, carbon material that was applied to the membrane and to improve the transport and desalination properties very much. So just to conclude, new type of the materials were generated. We use this inspiration by the nature, and what was important by this modification, we could tune selected properties and really to enhance the transport, enhance the separation, and mitigate fouling. So it was the most important. And the work, selected work related to this project already published. So if you are interested, we will be very happy to share our work. So thank you so much for your attention.
Thank you very much, Dr. Joanna. The floor is open for a couple of questions, if anybody is interested to ask her. Yes, Dr. White. Yeah, can you give him the mic, please?
Practical application of such membranes. I know that these membranes are operating at low pressure, very low pressure. Can be used for desalination. But to which pressure can be used? You know, desalination needs high pressure. Did you test the mechanical properties? Membrane distillation doesn't need any pressure. Yeah. Mm-hmm. Mm-hmm. So it is only ultrafiltration. Yeah. Okay. Mm-hmm. But for which purpose such membranes are useful now, or can be applied? Membrane distillation, yeah. Okay, thank you.
Any more questions? Can you give her the mic, Dr. Waid, please? Dr. Joanna, I have a question myself.
Okay.
So, no, to give her. I have my microphone.
Let me not
Give her because she wants to.
Okay.
Yes. You were concerned about modifying the surface chemistry of the substrate.
Yes.
What about the morphology of the asymmetric membrane? You are producing asymmetric membrane, right? In terms of hybrid membrane, 2 layers.
Yes,
One was by the modification of the surface, the other by functionalization with the group that you added.
With ketosone, yes.
So you did not show any data regarding the morphology, like porosity.
No, it was actually on where the roughness were presented from atomic force microscopy.
Roughness, you mean?
Roughness, but it was the table with the pore size as well, the minimum, maximum, and the average pore size.
The enhancement that I was concerned with is the level of crystallinity in terms of alpha divided by beta, which was 0.45, right?
Yes.
The crystalline form.
Yes, for this.
It was enhanced by adding this functional group,
for
right?
the final one, yes.
Did that enhance the porosity and as well as the other morphological properties?
The pore size of the membrane was a little bit smaller because we just added this material. So because of this, the pore size was 8% smaller, the average size of the.
But that did not affect the average flux.
No, because we introducing the hydrophilic character. So actually it works like sponge. So it's attracting water. For that reason, we observed the improvement in the water transport, and the activation energy of the transport was smaller for the modified membrane.
Thank you.
Welcome.
Any more questions? Thank you.
Thank you so much.
Thank you very much. المهندس عبد الله جداية. دكتور ولا مهندس عفوا؟ مش مبين عندي هون. ان شاء الله دكتور خلاص. Okay, shall I introduce him? Okay. Engineer Abdullah Jidaya, he's affiliated with the Jordan Engineers Association, served as Environmental Service Manager since the year of 1989 at Fair Deal Group, Management, and Fair Deal Marine Service, Greece and UAE. He has over 33 years of extensive technical and project management experience in the field of oil, spill response, and marine waste reception facilities and processing. Mr. Abdullah holds a Masters of Science degree in Chemical Engineering from National Technical University of Athens, Greece. He is certified lead auditor of both quality and environmental management systems. We welcome you to present your talk, and you have less than 20 minutes.
Thank you, Doctor, for the introduction. Just need to give you a brief about where I'm coming from. Actually, my company is a shipping company, but dealing with environmental subjects since 40 years back. Okay. So the company is established in 1978, dealing with marine oil pollution prevention activities and fighting. As well as we receive the oily wastewater from the vessels, which is produced in their normal operations, and we separate oil from the water using multi-stage gravity separation without adding any chemicals, just only with heating. We are very active, and the biggest private, we own the biggest private oil spill response center in the Gulf area, dealing with oil spills, as well as HNS, hazardous noxious substances. And here we are. I came here just to introduce to you the application of nanotechnology in waste management. We are using geochemical active clay sediment, relies on foundation of nanomechanics and the usage of geopolymer materials, high adsorption ability, is completely environmentally friendly process, applicable to wide range of oil, industrial waste, sewage, and in gas, liquid, and solid phase. The pollutant load is captured at nanoscale level on the surface of the geopolymer materials. And then the production of inert sludge, where the pollutants are steady, captured to the crystalline structure of the polymer. And this is in brief the whole process, the input, the liquid or sludge or solid, then the treatment through a reactor, which I will show you a little later, adding the polymer material, then the output, the water, inert solid, and which can be used wherever as it is harmless. This is the application in petroleum industry wastewater. It comes to the oily water separator, and we are using the geochemical treatment, capsulation or flocculation, then induced air flotation system. The sludge separated different, treated after the process. The oil water is separated from the oily water separator. The same process. These are the results before and after. You can see the COD from 4,730, it comes to 104. TOC from 2,000 to 99. NO3, 25,000 to 3.57. So you can see it's a very big reduction of the pollutants. This is another application for tank cleaning by adding the steam fluidizers, then compacted sludge, which is in the tank, can see in tank 1, then fluidizer, then progressive cavity pump to transfer after it become pumpable, then put it in a green shaker, then holding tank, progressive cavity pump, then decanter, and we get the solids and the holding tank. Another, the flow chart for this process: oily sludge, waste dehydration, belt conveyor, geochemical reactor, stabilization, neutralization, then biorehabilitation, treated inert for disposal. Yeah, so this is the outcome. It is stabilized, neutralized, and inert. So the capacity of this reactor is it can handle 24 cubic meters per day, working 24 hours, and 6 batches. Each batch is 4 cubic meters. This is the reactor, which is used for oil and for the solids, and can be converted to deal with water. We are bringing same reactor to Abu Dhabi, and it will be in operation within the coming 2 or 3 months. This is a sample of the contaminated solids, oily solids, before and after. another sample. You can see the big difference between the two. You can see the various stages of the wastewater from A to E, which is very clean and non-hazardous. This is the outcome before and after for the leachate. You can see the difference before and after, which is reduced up to 90% or 99%. This is an application in leachate. This is for scrubbers, air scrubbers, to deal with contaminated air, mainly from the industry and the sewage water treatment plants. Right now we are working with Dubai municipality because the main problem that they have is the odor, and we are working with them to provide them with special scrubbers to be installed in between the stages of the treatment. Again, you can see these are the flow chart for the treatment operation of the gas. So the application of this nanotechnology can be used for the municipal water treatment, industrial dangerous wastewater, landfill leachate, bilge water. Bilge water, we call this the used oil, which is used mostly in the ships or wherever. Bottom and fly ash stabilization, heavily contaminated sludge treatment, potable water plants. So you can see it can be used in metal industry, electrostatic painting, galvanizing, lubricants, chemical industry, building materials. Again, paint industry, pharmaceutical industry, power generation units, gas stations, fertilizer and pesticides. And the financial advantages of and benefits of the GACS method. It has a low maintenance cost, competitive investment cost compared to other treatment methods, significantly lower operational cost in use of chemical reagents, lower treatment units footprint, capability of treated water reuse, treatment of polluted water from any source of origin, installation on existing waste treatment plants also possible, optional automatic or batch type operation mode, no influence from climatic conditions, high quality standards outflow, according to legislation limits heavy metals removal, even if they are in high concentration. Production of inert biorehabilitated sludge, which can be disposed safely. Use of natural materials, toxic and dangerous inorganic sludge can be managed completely safe. Complete proposal for managing landfill leachate, removal of heavy metals, eliminations of odors. It can be applied to radioactive emissions as well. This is the key benefits for the environment, technically, economic. And we have received several awards for our services that we do provide in the Gulf area and in Greece before. These are the latest acknowledgements awards that we have received last year. The offices in Greece, in UAE, London, and China. So in case that of any interest from any side, we have to send some questionnaire to get the problem that they are facing. Then we come back with a proposal for solution. Thank you.
Thank you very much. Okay, we have room for a couple of questions if there's anybody interested to ask Mr. Abdullah concerning his topic. Okay, I have a question myself. All right.
Yeah.
Do you sell the technology for people who are interested in, treating
Yes,
their outputs, or you do it by yourself, by your company?
we do both.
Both?
Yeah.
You give the consultation?
We can, yes, we can sell the technology, the machinery, the reactor, but you will be depending on us, and we have to provide
the maintenance.
To sign, not the maintenance, it's mostly to provide you with the suitable particles to deal with the pollutants that you want to face.
Okay.
But we can make a commitment to provide you for the next 20 years with this material, because nobody else can manufacture this material. It's only the innovator from Greece.
Okay. Where do you send the finally treated sludge?
The final treated sludge, there is no any problem. There is no any toxicity. You can landfill it. You can use it for
construction, you mean?
Construction, I can't say, but you can see if you have some problems with some holes or whatever, you can put it safely without having any problem.
Okay. Thank you very much.
You're welcome. Thank you.
Now we move into our online lectures, starting with Dr. Kian Hong from Malaysia. Are you ready, sir? There? Are you there? Kian Hong. Atika Kadri.
Yes, I'm around.
Okay, I have to switch to you because I think the one preceding you is not available right now. Do we have her bio? Okay, let me introduce you first and then you'll commence your talk. Sure. All right. Atika Kadri, I hope I'm spelling the name right, currently serves as lecturer and researcher at the School of Chemical Engineering, College of Engineering, University Technology, Mara, Malaysia. Her research interests include non-gaseous hydrogen storage, nanocatalysis, of course, and enzymatic extraction technology. She is actively involved in consultation work and also an associate member of the Institution of Chemical Engineers at UK. Her talk will be about co-catalyzed with the MIL47, metal organic framework and carbon nanotubes for an enhanced MgH2 hydrogen sorption performance. You have 15 minutes, so wish you luck. Go ahead.
Right, thank you so much for the introduction. I'm going to present my work on co-catalyzed with metal organic framework from vanadium and carbon nanotube for enhanced magnesium hydride hydrogen sorption performance. Right, so I bid Assalamu alaikum warahmatullah to everyone. Before I begin, perhaps I'm just going to share my outline of the presentation. Today, first I'll be talking about the motivation, the research background, the problem statements, followed by the objectives and the methods that that is being applied, results, and some interesting discussion, and finally conclude the presentation. So allow me to begin by highlighting the motivation of this project. As we all know, fuel-powered vehicle actually a source of pollution, and we know that the dangerous gases, for example, like carbon monoxide, nitrogen oxide, are sourced of very harmful to our health. And thanks to the automobile industry, where they have actually moved forward in providing as an option of vehicle which runs without using the conventional fuel. One of the type of vehicle that I'd like to focus is the hydrogen cell fuel vehicle, and we are so blessed to have them ready in the market. And however, we know that if you are using fuel cell, the source of energy that need to be supplied is obviously the hydrogen. And this hydrogen has to be kept in the vehicle all along, and unfortunately, having this hydrogen being kept in cylinders obviously will consume space because it is off in a form of gas. And on top of that, having hydrogen being kept in gas obviously would have some safety concern, especially it's working at a very high pressure state. So that drives me to look into options of hydrogen storage material. And at the moment, what we have here is we have a common pressurized cylinder vessel, and we also have those using cryogenic state. And recently we have research work working on physisorption, looking at a metal organic framework or graphite to actually keep this hydrogen in physisorption form. And another option, which I think would be more interesting, is on using metal hydride. Why I focus on metal hydride, particularly on magnesium, because the fact that it has a high volumetric density of a value of about 110 kilogram of hydrogen for every meter cube. And it is working with a relatively low pressure as compared to, for instance, if I compare to Toyota Mirai, the working pressure is about 20 bar, and the volumetric density is about 110, working with about similar mass amount that is allowing for a reasonable traveling journey. So that brings me to work into magnesium as the material to store this hydrogen. However, having hydrogen being connected to magnesium would have things to be looked into. So the challenge is basically to overcome the strong ionic bond, which basically going to cause a in operating temperature, where it requires high temperature to release the hydrogen and also to absorb hydrogen. And on top of that, having magnesium also would cause some kinetic issues, because as having magnesium on its own only allow magnesium hydride to be produced, which eventually going to stop from new hydrogen bond to be connected to the fresh magnesium. So what is the main objective of this work is basically to improve the absorption kinetics as well as to look at the thermodynamic barriers. So to do that, we have actually applied a very simple process where we make use of metal organic framework vanadium base and as well as the carbon nanotube as the catalyst. So before we get to use this metal organic framework, we synthesize them, which I think this is fairly straightforward. We have vanadium chloride, terephthalic acid, and deionized water in a ratio of 1 to 0.25 to 100, being autoclaved at 200 for 4 days, eventually dried and washed and dried, and eventually you'll be able to get that metal organic framework. So we use this morph where in preparation of the magnesium hydride material for storage purposes, the magnesium hydride first is being ball milled using a high energy ball milling machine with a ball to powder ratio of 40 to 1. So that allows about 2 hours of milling before we introduce the catalysts, which are the carbon nanotube as well as the metal organic framework. And following to that, we continue the milling for another 2 hours. So in the end, we'll be able to come out with products. And as a benchmark, we also produce the pristine magnesium hydride, where we ball mill in the same period of time. And we also produce other combination of magnesium hydride, where we have only catalyst of carbon nanotube or the metal organic framework, just to see whether the real effect of the synthesized or the synergistic effect of both. So the analytical equipments that we use are the XPS, just to see on the surface chemical composition as well as the valence state, particularly looking into the metal organic framework changes as we mill and as well as during after charging and discharging. We also use Xrd to check on the microstructures, and TEM as well to look at the dispersion of the catalyst. The PCT, pressure, composition, temperature, to look at the performance of the material, the magnesium hydride storage material, and TPD to look at the desorption performance. So let's get on to the results. On this slide, we have the prepared metal organic framework. We have successfully synthesized the MOF, and it matched with the database. And from the XPS data, we realized that it has a 2 oxidation state, valence 4 plus and 5 plus. And we're expecting something is going to change later as we use this metal organic framework in the magnesium hydride material. So for the magnesium hydride storage material, we got to see the TEM image, and we able to provide the dispersion of the catalyst by looking at the spot analysis. And fair enough, we have the metal organic framework as well as the carbon being fairly distributed, as shown in figure 2B. And the particle size is rather very small, obviously less than 50 nanometer. Now, in terms of the oxidation state of the metal organic framework that is being incorporated in the magnesium hydride system, we realized that the valence state, another valence state appear, which is 0 valence state, instead of having just the 2 oxidation state. And indeed, this is basically taking place as milling, where high energy milling is being imposed, which cause the oxidation to be reduced to its 0 state. As for the Xrd result, we noticed that the peak is rather broad, referring to the very small particles that is available after the milling. And we have both beta and alpha magnesium hydride states. So this is a allowing us to see that the possible of creating magnesium hydride in the system. Now, looking at the performance-wise, for absorption, hydrogen absorption, which is taking place in 100 degrees C, we can actually see the performance of each individual samples as compared to the pristine magnesium, which is shown by the signal in pink in color. We can actually successfully able to improve the kinetic of hydrogen absorption and at higher temperature, for instance at 200 degrees C, the ultra fast charging happened less than 1 minute. So indeed, this is something very, this is an excellent absorption capacity for a magnesium hydride. As for desorption, the desorption is being investigated at a temperature of a range of 300 to 260, and we can actually see that the releasing of hydrogen may happen within 10 minutes for a 300 degrees C, and if we were to look at a lower temperature of 280, more or less after 20 minutes, the samples, all samples except for the pristine magnesium, able to reach to almost 5%. And most importantly, we can see that the sample, which consists of the metal organic framework and carbon nanotube, surpass the rest of the sample prepared and obviously show the synergistic effect having both to be available in the system. And as for the TPD result, we can see that the temperature had actually shifted to a lower temperature when we have the combination of metal organic framework and carbon nanotube. And we also can see that the optic temperature is also reduced to 180 degrees C as compared to 310 degrees C of a pristine magnesium material. Moving on to the thermodynamics, we have actually looked into the thermodynamic properties, the desorption enthalpy. We found out that having to use both metal organic framework and carbon nanotube, able to reduce the desorption enthalpy as well as the desorption entropy. Indeed, we can alter the thermodynamic property of the magnesium by having this catalyst, the combination of this catalyst. For cyclic substability, we've run a 6-cycle test, and we also found out that the performance of absorption and desorption does not change much. So this shows that the material able to have multiple charging and discharging. And if we look closely at the metal organic framework that is present after the charging, we realize that there's no much change in terms of the oxidation state. It remains as it is, as how it is when it already being fully synthesized. So all in all, I could say in conclusion, we managed to look at the option of a catalyst where it enabled to have hydrogen absorption taking place as low as 100 degrees C, and allowing a system where it can be recyclable, it can be withstand cycle activity. And with the fact that we have this metal organic framework, it is stable because it doesn't change in terms of its oxidation state, and it allows to have a large surface area where it is in contact with the magnesium surfaces to allow catalytic activity, and having carbon nanotube serves as hydrogen diffusion channel, which eventually add enhancing to the hydrogen storage capability of the material. So I also like to acknowledge the Australian Research Council as well as University of Queensland for supporting this work, and as well as University Technology for providing the fund. With that, I'd like to say thank you. So I welcome any question.
Thank you very much, Dr. Atika. So any questions? Any questions? Oh, should I? لازم أسأل أسئلة. I have a question myself. Huh? Okay. You want? Okay, there's a question for you. Can you hear me?
Yes.
Okay. Go ahead.
Thank you very much, Dr. Atika, for the nice presentation and for the excellent work you have done. I just have a couple of questions. The first one, I know there's a motivation for doing this work. So what is the motivation and in terms of applications? So what are the applications you are targeting?
Right, thank you so much for the question. After we realized that the performance of hydrogen absorption and desorption able to reach to such huge capacity, nearly to its maximum, because for magnesium hydride, the maximum region is about 7.6%. So able to reach to 6% obviously offers a lot of options in terms of application. We're looking at not just about mobile application as what I have shown you earlier to substitute the cylinder, the hydrogen cylinder in vehicle for fuel cell. We're also looking at the option of able to transport hydrogen or to deliver hydrogen in mass. Probably if we're thinking about transporting hydrogen from one point to another without using any usual cylinder tankers. So this is another way of application. On top of that, we also have the intention to look at supplying hydrogen in hydrogen station to allow supply for hydrogen cars, and as well as for energy to produce electricity.
Have you also studied the release kinetics of the hydrogen?
We only looked at the absorption kinetic at the moment. We yet to look at the release kinetic. We realized that it requires high temperature at the moment, which is about 300 degrees C. So we are looking at some strategy to actually increase the kinetic at a lower temperature.
Okay, thank you very much. I know that the release is the most challenging part of the work, right?
Exactly,
yeah.
Exactly, yeah.
Thank you very much.
Thank you very much, Dr. Atika, and we were glad to have you in our conference. Thank you very much, and looking forward to have you in our coming conferences, inshallah.
Thank you. Thank
Assalamu
you so
alaikum.
Alaikum salam.
We try to inspect if GAN is available. GAN Kian Hong. Mr. GAN Kian Hong مش موجود ها؟ Okay. دكتور عبد الحميد الوعد. دكتور عبد الحميد. Dr. Abdul Hamid, are you there? Mr. Gan, are you there? Abdul Hamid? Abdul Hamid? والله ما في غير أنا وياك ضل خلص. Okay, we'll wrap it up. That's it.
Technology applications in chemical engineering. Our first lecture will be with Dr. صغير عنيزات. Dr. صغير is from KFUPM, جامعة البترول, جامعة الملك فهد للبترول والمعادن, Chemical Engineering Department. His research interests include wastewater treatment, natural gas desulfurization, CO2 capture, and drilling applications. His lecture will be under the title of CO2 capture by graphene-based nanocomposites, effects of oxygen and nitrogen contents. The floor is yours, Dr. Nizar.
Assalamu alaikum. Good afternoon, everyone. It's my great pleasure to stand in front of you and present to you our recent work on CO2 capture by graphene-based materials. We are just embarked on this topic recently, so what I'm presenting here just preliminary study on what we have done so far. This will open the door for us to optimize the synthesis process and also the capture. So as I said, it's just preliminary study on what we have achieved so far. So the title, as you see on the screen there, is CO2 capture by graphene-based composites. The topic is not new, so there are some works on CO2 capture by graphene materials, but there's a lack of studies on the effect of oxygen and nitrogen, which we are targeting in this recent work. Okay, I'm sure all of you are aware of the bad consequences of global warming. We have seen some of the recent events on the resulting from the global warming, like for example, floods, hurricanes, and many more, which are all stemmed from the global warming. So this one is associated to the greenhouse gas effect. One of the most important greenhouse effect which is present in the atmosphere is CO2. CO2 is required, but we have to balance it. It should not be too high and should not be too low. So if you see the graph on the left, the CO2 concentration was like in the around 300s like 1 century ago, and started increasing, and it's now almost 415 ppm in the atmosphere. This number as a number is small, but the consequences of this number are huge, because according to experts, the level of CO2 in the atmosphere should not exceed 350 ppm. Okay, what will be the result if we have higher concentration of CO2 in the atmosphere? The graph or the chart on the right shows you some of the bad consequences or effects. With increasing CO2, they will have the greenhouse effect, and the temperature of the universe will increase. One direct result for the temperature increase is the melting of the ice caps in the poles, north and south, which will ultimately increase the sea level. Plus, with the increase of temperature, we'll have more warm weather. The ecology of the Earth will change, and we'll experience some of severe diseases, some of them new, some of them old, but with the changes in the ecosystem, the severity of these, which usually used to be mild, it will become more severe. So we have to take actions on this matter, and we have to reduce CO2 emission. As I mentioned, that topic is not new, and there are a lot of work done on this topic, but the room for improvement is still wide and still big, because most of the work done so far either proved to be unsuccessful, or there are some bad effects or some disadvantages of the work done so far. Okay, so the work done so far on CO2 capture can be grouped into 4 categories. The first one is based on amine absorption or on absorption processes. The next one or the second one is membrane processes. Third one is adsorption, and fourth one is chemical looping. Under absorption, we have different processes according to what is the solvent used to capture CO2. The most commonly used ones are amine-based materials, and this is the most widely used through all, or among all the processes. We have also alkaline solutions, we have ionic liquids, we have ammonia. Amine-based absorption processes, alkaline solutions, and ammonia, they are already commercialized. And the third one, ionic liquids, is on pilot plant scale. For the membrane processes, we have different materials that can be used to synthesize the membranes, and they can be classified into inorganic materials, polymeric, facilitated transport materials, and mixed matrix membranes. Among these, the polymeric material is already developed on commercial scale. The others are still under research or lab scales. Adsorption, which is our topic here, we have several adsorbents, but they can be grouped into zeolite materials, carbon-based, MOFs, metal oxides, and supported amines. Chemical looping, we have the combustion looping and reforming. Okay, as I mentioned, absorption is the most mature one and the most widely used one. And under this category, we have the amine-based materials, the most widely used, and they are applied on large commercial scales. And most of the processes in industry is based on amine absorption processes. Why we are not happy with it? Because there are some consequences. Yes, it is good. It is mature in terms of maturity, it's mature. And also it is, in terms of the scavenging or the removal of CO2 capacity is quite good, can be above 90%. But it has some limitations. One of the limitations is the energy consumption during the regeneration process, because we cannot throw the amine solution, we have to regenerate it. And that consumes a lot of energy during the regeneration process. And also the degradation of the amines used, and we have to top up the amine solution frequently, and also the release of the amines, because we cannot avoid the leakage of amine to the environment. So there are some also environmental concerns on the use of amine and also during the manufacturing of the amines used for the absorption process. So it has some limitations, and the limitations, they are somehow serious, especially the energy consumption, the environmental ones. So for these reasons, the other methods mentioned there are tried, and some of them are showing promising results. One of the attractive processes is adsorption, because adsorption can be done under mild conditions. And if we can come up with good adsorbents, we can maximize the absorption or the uptake capacity of CO2 and also save in terms of the cost for the regeneration, and also adsorption usually more environmentally friendly than amine absorption processes. Okay, but one of the key requirements to have good adsorption process is to have good adsorbent. And to come up with good adsorbents, there are a lot of requirements. Some of them is the nature of the material in terms of the porosity, the surface area, and also the interaction between this material and CO2, and how easy to upgrade this material to improve the CO2 capture. Recently, like 2 decades ago, graphene has been discovered, and the properties of graphene are very attractive for different applications, not just for CO2. As you can see on the slide there, it has been applied to hydrogen separation and storage, natural gas separation, wastewater treatment, desalination, CO2 capture, a lot of applications. And also not just for the environmental application, but also for sensing processes. There are many sensors developed based on based on graphene material for electrochemical applications, enzyme-based applications, and many more. So it is attractive, and for us in this work, what attracted us is the surface area. It can has huge surface area, and also the strength, because this material can resist the tear and wear during the applications. Yes. For the preparation of graphene, there are two approaches. One called bottom-up, and the second one called top-down approach. For the bottom-up, we start with small molecules and grow these molecules into a sheet of graphene, which consists of many, many atoms. For the top-down, we have the graphite as the starting material, and when we break, because graphite consists of many stacked sheets of graphene, we can break these sheets into single sheets, ideally single sheets or small number of sheets, and get the same as if we go up from small molecules. The top-down approach is more attractive because it's easy. It's easy to do, and it's also cheaper to do, because to build up this huge sheet, it's very challenging. So the top-down, bottom-down approach is more attractive, but one of the limitations is that you cannot generate, you can generate it, but it's much easier to generate graphene oxide first and then convert into graphene. To convert or to decompose the graphite into sheets of graphene oxide, there are three key methods used for the conversion of graphite into graphene oxide. The first one called Brodel method, and here the materials used to oxidize graphite into graphene oxide is, they are basically fuming nitric acid and potassium chlorate, in addition to other additives as well. For the second method, it's called Strondium-Meyer's method, and also uses concentrated sulfuric acid and potassium chlorate among also the the nitric acid, concentrated nitric acid. Speed up. Okay. So, for the preparation, can you go back? So as I said, there are three methods. The third one is called Hammer's method, and the Hammer's method is more attractive because it doesn't use toxic chemicals, and also the byproduct generated is less harmful than the others. But even for the Hammer's method, there are some versions of the method. The most attractive one is called improved Hammer's method. So here we don't generate any toxic gases. And also the conversion process is much more effective. So we oxidize almost all the graphite into graphene oxide. Once we have graphene oxide, we can do some processes like reduction, sonication, exfoliation to convert it into single sheets of graphene oxide. And then we can, if we use the reduction, we remove the oxygen functional groups and convert it into graphene. Of course, the graphene generated from here is not exactly the same as the graphene from bottom up, but it has almost properties that are representative to graphene. And we can also do a lot of functionalization and modification of the graphene we obtain from here, or the graphene oxide, to tailor the properties of the graphene material to the desired applications. So what we did here in this work, we started with graphite, and from graphite we prepared graphene oxide according to the improved Hammer's method. And then after that, we did the reduction using three different approaches. The first one using zinc and hydrochloric acid, and the second one using aluminum foil and hydrochloric acid, and the third one is using the mixed zinc and aluminum foil with sodium oxide. These different reducing agents will have different effect on the functional group or the oxygen content in the graphene oxide. And if you can see on the left, or the right, sorry, we have the the carbon-oxygen ratio. The higher the ratio, the better the reduction of graphene oxide into graphene. Ideally, it should approach infinity because you don't need to have oxygen functional group, but that is quite challenging. So if you can see there, we have the first one called RGO, which we use zinc and hydrochloric acid. This gives us the highest CO ratio, means that it is the most effective reducing agent. After that, we characterize the material we obtained, and also our target also to include nitrogen, so we functionalize the obtained graphene oxide and the reduced graphene oxide with different amines. After the synthesis, we characterize the material just to make sure that we have the material we are looking for. And if you look into the top panel there on the left, we have RGO2, RGO1, and RGO3, and then GO. This peak here corresponds to the oxygen, the hydroxyl group. So this one gives us indication on whether we have reduced the graphene oxide effectively or not. As you can see there, the peak for the graphene oxide without reduction is quite intense compared to the other three materials. And RGO1 is the peak intensity is the lowest, means that it is more, the reduction there is more effective. We have also modified, as I mentioned, graphene oxide and reduced graphene with amines, and the spectra, the FTI spectra shown on this slide, confirm the presence of amines on the graphene oxide. We have also done XRD to just check the crystallinity of the material and the effect of the functionalization on the crystallinity of the material. The lower curve is for GO. We have the angle is around 10 degrees, and when we reduced the graphene oxide, it shifted to around 25. This is a kind of qualitative confirmation that we have modified graphene oxide or reduced it. Then we functionalize it with the amines, this amine called ABTS. It was shown on the previous slide, and we also modified the reduced graphene oxide with ABTS. 1 minute. Okay, can you jump to the results? Okay. Just jump. Okay, so these slides here show us the effect of oxygen and nitrogen content on CO2 capture. The top one, comparing the graphene oxide to reduced graphene. For the first one, we have the graphene oxide. We have the oxygen atomic content is around 35%. For the reduced graphene oxide, it's about 8%. So when we have higher content of oxygen, we have better removal of CO2 or capture of CO2. This one is not related to surface area, as you will see later on, but mainly for the oxygen functional group. We also modified the graphene oxide and the reduced graphene oxide with the APTS, and here we include the nitrogen content or atoms in the graphene material, and because we're talking about percentage here of atoms, so yes, we have included nitrogen, as you can see there, and it's amount about 9%. There's a little reduction on the content of oxygen, but yet we have higher CO2 capture. So this means that we have also the effect of nitrogen there. So we reduced a little bit on the oxygen content from 35 to 33%, and increased we have now the nitrogen content about 9%. So this improved the CO2 capture, and also we did it for the reduced graphene oxide. There's improvement compared to the base material, meaning that with including the nitrogen functionality there, we have improved capture for CO2. Yes, next one. Next one. On the left there, the top one, we have different amines, and you can see there that ABTS Next one. ABTS is the most effective. It contains, this material contains 9% atoms of nitrogen and 33% oxygen. When we change this one into diethyl triamine, DATA, the next curve below the top one, we here increase the nitrogen content to 12%, but we reduce the oxygen content to 30%. So as you see here, the CO2 capture reduced, and we also functionalize with the polyethylene amine, which contains a lot of nitrogen atoms, so the percentage increased to 17%, and the oxygen content dropped to 22%. So this means that it's not open, so you cannot just increase the number of oxygen and number of nitrogen, and you expect that you will get better CO2 capture. So there's a balance, as you can see here, that we have to optimize. Okay, so it's not just arbitrary. You just increase, and you get better removal for either nitrogen or oxygen. You have to balance it. So the ratio of oxygen to nitrogen is quite important here. We don't claim that we reached the optimal one because, as I said, this is just preliminary screening work. But we believe that since we have this observation here that shows us both nitrogen and oxygen are contributing, but there's an optimal level for each one of them, and the ratio probably. So we can expand on this one. On the slides, the graph on the right, also for the same material, ABTS, but when we change the ratio of the ABTS to graphene oxide, we have also different responses, indicating that even for the same material, you have to optimize the level of the oxygen and nitrogen content. So the key conclusions from this work, that if you use zinc and hydrochloric acid compared to the other two, this is the most effective one. So it gives us quite high carbon to oxygen ratio. As I mentioned, with increasing the carbon to oxygen ratio, you get indicative that the reduction is better. So we can increase it from 1.8 for the base material graphene oxide to 11.2 for reduced graphene oxide using zinc and hydrochloric acid. For the capturing of CO2, the presence of nitrogen and oxygen definitely improve the capture, but you have to be careful with the optimization of the composition of the material and the ratio of nitrogen to oxygen ratio. So DTA and PEI, also they don't contain oxygen and only contain carbon and nitrogen. They are, in terms of the elemental composition, for example, they contain both carbon, hydrogen, and nitrogen, but they respond differently according to the amount of nitrogen in the material. So with the PAI, we have more nitrogen content there. I'd like to acknowledge the support from the Deanship of Research Oversight and Coordination at King Fahd University of Petroleum and Mineral for supporting this research in terms of intergrad of DF 191027. And thank you very much for your listening and attention.
Thank you, Dr. Arnaizi. We have room for one question, maybe. Any questions? I have a question. Yes. For the DDTA, did you study the effect of the ratios, the concentrations?
We are doing it now. We haven't done yet, but we are working on it. Also, we have observed similar trend as with the ABTS.
Okay. So because of the number of nitrogen.
Yes. So if you increase or decrease, you alter the ratio of carbon nitrogen content, and therefore you see different response.
Because that's expected because we have different number of nitrogen atoms, and the structure of the DTA maybe is more complex than the ABTS. No, the structure of DTA is similar than ABTS. The structure of BEI is more complex. Yes. Okay. Yeah. Anyone have any question? Thank you, Dr. Arnaizi. We will move to our online session now, online lecture. Online. Yeah, now it's, yeah, Dr. Muhammad. Our next lecture will be presented by Dr. Muhammad Ashraf Ali. Dr. Muhammad has is working as Associate Professor, Chemical Engineering Department, College of Engineering, Jazan University. Before that, he was at King Fahd University of Petroleum and Minerals as a research scientist. Dr. Muhammad achieved 13 patents, awarded 12 patents published, and 5 patents pending at U.S. Patent Office. He published more than 130 research papers in international journals. He has more than 30 years of research experience in refining, petrochemicals, catalysis, and products development. He has contributed several research projects for SABIC, Saudi Aramco, and many other big companies. His biodata is really extensive. I don't want to waste the time. I want to give you the floor. Dr. Muhammad, please start your presentation. Thank you.
Can I start? Assalamu alaikum. Can I start my presentation? Okay. Bismillah ar-Rahman ar-Rahim. Start with the name of Allah, who is merciful and passionate. Nahmaduhu wa nusalli wa nusallim ala habibihi al-kareem, sallallahu alayhi wa sallam. The title of my talk is Synthesis of Silver Nanoparticles Loaded Nanotitania Catalyst using Mechanical Ball Milling, which is used for phenol photodegradation.
Dr. Muhammad, sorry for interruption. Can you increase the volume because we don't hear you clearly? Can you increase the volume, please?
Your sound is not clear, actually.
Dr. Muhammad,
Your voice
can
is
you hear
not
me?
clear. Should I start?
Yes, but we can't hear you.
Okay, I will start my presentation. Okay?
Dr. Muhammad, can you raise your voice, please? We don't hear you.
Okay, I will start.
Please check the setting of the volume.
Your voice is not clear.
The sound setting, probably check. Please check.
I will start my presentation, okay?
Dr. Muhammad, could you please increase the volume level? We don't hear you.
Your voice is not clear. I cannot understand what you are saying. Okay, I will start my presentation, all right? Bismillah ar-Rahman ar-Rahim.
دكتور محمد سامعنا؟
السلام عليكم. Dr. Muhammad? Dr. Muhammad?
سكر ميكروفون.
We don't hear you. The volume of your PC is not quite high, so please increase the volume. We don't hear what you say. Could you please increase the volume and check the setting if there's a problem with the setting?
بس ارفع الصوت دكتور محمد، مش سامعينك.
We don't hear you, Dr. Muhammad. The voice is not clear. It's quite soft. We don't hear you.
Okay, I will start my presentation.
So could you please check if the issue is with your PC? So increase the volume if possible.
Your voice is not clear. I cannot understand what you are saying. Please try to understand what I'm saying. Your voice is not clear at all. Okay, so let me start the presentation. Bismillah ar-Rahman ar-Rahim. Nahmaduhu wa nusalli wa nusallim ala habibi al-Kareem sallallahu alayhi wa sallam. The title of my talk is synthesis of silver nanoparticles, loaded nanotitania catalyst using mechanical ball milling. And this catalyst is used for phenol photodegradation. The content of these presentations are preparation of the catalyst, which is silver, loaded over nanotitania and used as a photocatalyst using ball milling method. And the reaction procedure using the catalyst. Then I will talk about characterization of silver nanotitania catalyst. Photodegradation results of phenol will be discussed. Kinetic study done for the results will be discussed as well. Some comparison with the results from the literature and a proposed mechanism of phenol photocatalytic mineralization. And at the end, I will discuss about the conclusion.
Assalamu alaikum, Dr. Muhammad. We still don't hear you. We still don't hear you. Could you please check if you have the issue from your PC?
Preparation of silver nanotitania photocatalyst using mechanical ball milling method. So this is the procedure which is given by this diagram. Gents, please turn your mic off. We cannot hear Mr. Muhammad. Admin, please turn everybody mic.
Dr. Muhammad. We don't hear you, Dr. Muhammad.
Yes.
خلاص تمام شكرا لك دكتور شكرا انتم مش سامعين بعدهم مش سامعين بس من وين المشكله؟ من هنا ولا من هناك؟ مش من عندي طلعت من هون عند السيستم اليوم سويته اونلاين برزنتيشن كانت اوكي؟ كل شيء تمام
الناس بتنسى 30 محاضرة بتذكر واحدة بس اللي قاعد هناك.
السلام عليكم.
Testing. Testing.
Hello.
Test. Test mic.
have different factors affect the water quality in Jordan. As I said, there's the natural resource scarcity, the climate change, the high population growth. All these factors affect the water sector in Jordan, and mainly affect the inland water sector. Mainly, as you know, the dams is one of the main water sources in Jordan. So this factor will affect highly the water in the dams. So this will be a big challenge for the governments and the water sector to manage and monitoring the inland water body. So to monitoring inland water body, we have the traditional monitoring programs, well, actually based on going to the field, have water sample, collect sample, then go to the lab and make the water analysis there. This is the traditional method, okay? This method will costly, it's time consumer, effort consumer. So on the other hand, there's the remote sensing techniques. Remote sensing techniques provide a new technology that can monitoring the water in efficient way, and it will be more cost efficient, also less effort. So the objective of our research project is to collect water quality data from different sites across Jordan. Then we will develop a mathematical model that can produce historical maps without need to go to have inside measures. Also to enable remote monitoring concentration for different parameters in different time. So in this regard, we decide to work in 3 parameters. We start with the chlorophyll A, and we have finished this parameter and published a paper related to that. We can find it through this link. And right now, we're working on color dissolved organic matter with CDOM, and then we work on turbidity. And the general objective of our project is to improve the performance of water management sector in Jordan and develop an early alarm system for water quality. So, in theoretical, how the remote sensing techniques works. Water parameter will have effect on the water color. This effect will change the water column and the water surface. This effect can also change the energy spectrum reflectance from the surface water, okay? This effect can be detected through the remote sensing. So the remote sensing technique will detect the reflectance from the surface, okay? This reflectance will reflect the water components in the water surface. So, in general, we have 2 data sets, so, to develop our methodology. We have, inside water sample, we go to the dams, have inside water samples there, and analysis the selected water parameter in the lab. This is one set data. Another set data is the satellite image. We done the field visit in the same day with the satellite image to avoid any time lag between the satellite image and the inside measurements. So the satellite image run with different process to, one of them, it's the atmospheric correction. So we do atmospheric correction to avoid the atmospheric effect on the satellite image. So we have right now 2 set data, satellite image data, and inside the parameter, okay? We use this to set to develop a logarithm model. For the CDOM, we use a semi-empirical method because CDOM have a direct effect on the water column, okay? So semi-empirical mean that we will base the empirical method on some of the optical properties of CDOM. Like we know that if the CDOM has a high concentration in this water, will be affect the green and blue region. So we will base our model to focus on those bands. After that, we will develop this we will develop the data set to set validation and calibration to develop our model. Okay, so we have selected 3 dams in Jordan: King Talat dams and Wadi al-Arab dams and Mujib dams. We have selected those dams because they have a critical role in the water sector in Jordan. Also, we expected the water quality will be different in those dams. We'll find a different water quality in each dam. So, for the result, we start with the calibration regression model. We developed different model. We tested more than, I think, 20 to 25 models based on the literature to find the best performance model. Okay, so based on the calibration result, we found that the model based on band 3 over band 2, which the green bands and the blue bands, as expected, will give the best performance. So after the calibration, we go to the validation regression model. In the validation, we bought another set of data. We didn't use it in the calibration, and compare between the predicted CDOM and the measured CDOM in the lab. And we found that the R square can be reached to 0.83, which is acceptable and give a good indicator. So this is also for the validation. Next one. As conclusion, according to the output result, we can find that we can use Sentinel-2 image and satellite image data to detect the CDOM. Also, we can find that the semi-empirical method that we use it here can provide a good and a fit model. Also, we found that, as expected, the blue to green ratio model provide the high capacity to protect CDOM. For the next step, we go here for the CDOM, which have like a direct relation between the CDOM and the water. It's have like a direct reflect on the water optical properties. The next step in our research project to invest the capacity of remote sensing data to detect the turbidity. Turbidity have like indirect effect on the water color. So CDOM have like a direct effect, CDOM and chlorophyll A have direct effect. Turbidity have indirect effect, so we in the turbidity will use the empirical method, not the semi-empirical method to develop our model. Thank you.
Thank you very much, Muhammad. If there is any question about the presentation, we may have the opportunity just for one question here. Are we all good? Okay. If you may allow me just for, you can have a seat. If you may allow me just for a couple of minutes, I will talk about this topic. This is a new trend in research in water and environmental engineering in general. It's about the application of remote sensing Muhammad is probably one of the brightest students that I've ever taught in my life. We've been working on this with remote sensing. Instead of doing the online measurements and going to the site, which is costly, time-consuming, and needs lots of manpower, instead of doing that, what we do, we developed a model, and we were able to successfully use this model to predict or to actually estimate the water quality of inland water bodies in Jordan without doing the actual measures. So you can monitor the water quality of several water bodies without doing the measures, just by sitting at your office. Now, what we did to develop this model, we started with the first parameter, which is chlorophyll A. We have already published the first paper regarding this, and we developed a model for the prediction and estimation of chlorophyll A in water bodies. The presentation that we've just watched with Muhammad was about a second parameter, second water quality parameter. How we do it, it's the same approach. How we do it, we take the satellite image, we analyze the different bands of lights, which is a result of the reflectance of light, sunlight. Depending on the different types of wavelengths reflected by the surface of the water body, you can actually estimate the concentration of different contaminants in water bodies, in dams and lakes and so on. So we started with the first parameter, chlorophyll A. We got a good results. So this encouraged us to do the second step, which is CDOM. After we developed the model for the CDOM, we moved to the third step, which is estimating the concentration or the level of turbidity in different water body by analyzing the satellite images. And this is what Muhammad is going to present next, I believe, right? So we'll give the floor to Muhammad again.
So, for the next presentation, we work for the another parameter, which the turbidity in the water. So, in this phase, and as I said, the chlorophyll A and CDOM have a direct effect on the water color. Turbidity will have indirect effect. Okay, so in this method, in this paper, we will use the empirical method to develop a protective model for turbidity. What I mean by empirical method? In empirical method, we don't have any base or optical, physical water quality base to start from it. So we will try to examine every single model we can do it. We have in Sentinel-2, we have around 8 bands. So we will try to develop the model using these bands, the 8 bands, also to protect the band index, like band 1 over band 2, band 2 over band 3, to have like a large set of data and test all of this data to develop our model. So, turbidity is an essential indicator for inland water, as it direct affect the water light penetration. And this will have like effect on the water quality and the color of the water. So, next one. Next one. So, for this paper, our objective was to determine the level of turbidity in the selected dams and investigate the potential of empirical method to develop a turbidity models. Okay, well, this two objective will help us to reach our main goal, which is to improve the performance of the water management and develop early alarm system. For early alarm system, when we developed a model based on remote sensing, we can, after that, like use the new satellite image, like Sentinel-2 have 5-day image. So every 5 days, there's a new image. When we developed our model, so we can use the new satellite to detect the water quality in the dam based on these models. So this is what we mean by developed early alarm system. Next one. So we use the same methodology for this paper, but here we use the empirical method to develop the algorithm. Next one. So for the result, also for the turbidity, we found that the turbidity level is the highest in King Talal Dam, then in the Mujib Dam, and then the Wadi Arab Dam, and the last one in the Mujib Dam. So turbidity level in King Talal Dam is the highest one. And this difference can like help us to provide our model in different level of turbidity. Next one. Okay, for the result, here we try a lot of models, more than I think 200 or 300 models, because we use empirical methods, so we try to develop as much as we can models. So the best performance models here was the use of, it's band 8 over band 3. So for the calibration also, we validate the data. Next one. Next one. Also, we use the same for validation. We compare the measured data of chlorophyll A in the field and the protected data of, the measured data from turbidity in the field and the protected data of turbidity from the developed model from the satellite image. Next one. So here we found that the R value which reached 0.83, what's also acceptable. Next one. As conclusion, we found that the empirical model method also can be able to used for detect the turbidity concentration using the satellite image. We found that band 8 over band 3, which near infrared to green, it's provide the based model. Also here we found that we can use the satellite image Sentinel-2 for detected the turbidity in different water bodies in Jordans. Next one. So for future work, right now we are thinking about to validate the accuracy of our developed model in different and other Jordanian dam. So we work in 3 dams. So right now we think about work in another dams. Also we think about try another water equality behind chlorophyll A, CDOM, and turbidity. Try another water equality parameters, and produce historical model also. The satellite image can give us a new satellite, and also we can go for historical data. So for the Sentinel-2, there's a historical data from, I think, 2015. So we can go back and see how the water equality changed during this period. Thank you.
Thank you very much, Mons Asaf. Is there any question here? Yes, please, go ahead. Good timing.
Thank you for your valuable presentation, really. But I have a question, please. Is it the turbidity that indicates the contaminants or the level of dissolved salts, for example, or any other contaminant in the water? Or
Yes.
there are other parameters that indicate that? Is the salt solids cause the turbidity or increase the turbidity of water? Is it a must? Thank you.
The turbidity is actually the presence of undissolved solids. Okay, so for dissolved solid, they are dissolved. They may change color. I'm sorry? Yeah, they may change color, okay, for the dissolved matters, but they won't affect the turbidity as much. What we're trying to do here is to examine different parameters so we can help decision makers. The ultimate goal of our work is to build an early alarm system because some of the sources for our water supplies comes from surface water, you know this, from dams. So what we wanted to do is to keep an eye on every single source, make sure we monitor the quality of that water before using it, okay? How we do this? Just by analyzing satellite images instead of going and examine every single source. And we've been successful in doing this for 3 parameters so far: chlorophyll A, turbidity, and CDOM.
Arose to my mind really because it says, the slide says that the turbidity is a measure of the quality of water. That what one factor. Yeah, thank you. Thank you. Clear.
Yeah. I'm sorry, I have to chair the session and be a presenter.
Short question. Thank you for the good presentation. Actually, I am as a guy who was working in the industrial field, in the chemical industry, and it is beside the Dead Sea. We are facing issues with the turbidity or the turbid water that comes from like Mujib Dam. Yeah. My question here, what are the parameters that you use to build up this model? The first one for the turbidity specifically. The second thing, did you take the time or the weather, when it's rainy or when there is like flowing water going to the dams, and how it affect your production and the remote sensing?
Okay, I will go for the second part because I'm not here the first part. For the second part, yeah, actually one of the challenging for using remote sensing is the weather condition. For that, we use atmospheric correction methods to correct the effects. As you said, if the weather is cloudy, this will affect the quality of the image, so we cannot use it. So for our work, we try to avoid any clouds. We work in summer with a clear sky to avoid this effect. Yes, for the model. Yeah. What's the first part? Sorry. Yeah. In turbidity we use empirical method. So we analyze the wavelengths and we try to make as possible as we can models. Like we work with Sentinel-2, we have like 8 bands. So we try all these bands. Then we try the band index, band 1 over band 2. So it's more trial because we use empirical method. Yeah. Okay, great.
Is there any other question here? All right, thank you very much, everyone. Thanks, Muhammad. Thank you. I will leave the floor to Dr. Huwaiti, who just saved the day, by the way.
Good morning, ladies and gentlemen. Let me first introduce myself to you. My name is Muhammad Al-Huwaiti. I'm the Director of the Research and Business Development at the Jordan Phosphate Mines Company. It's my pleasure and honor to join you in this session. Now we get to start with the next speaker, Mr. Ibrahim Daboubi. Good morning, Dr. Ibrahim. Can you hear me? Dr. Ibrahim, his research entitled Pyrolysis of High-Density Polyethylene Artificial Neural Network Modeling. Dr. Ibrahim is the Chemical Engineering Department at Saudi Arabia. He got bachelor's degree in the Chemical Engineering from Baghdad, the master's degree in Advanced Chemical Engineering from UMIST England, and the PhD in 1993 in the Chemical Engineering from the Salford University of England. So, Dr. Ibrahim, the floor is yours, please. I'll give you 15 minutes to finish your talk. Please go ahead. عامل ميوت لا سامعنا ولا ميوت Dr. Ibrahim, can you hear me, please? Dr. Ibrahim, I guess your mic is mute. Dr. Ibrahim, please, we didn't hear you. Dr. Ibrahim, please, do you hear me? We couldn't hear you, Dr. Ibrahim. Dr. Ibrahim. Can you hear me? هاي مشكلة الأونلاين. Dr. Ibrahim, can you hear me? Please, maybe the voice or the speaker in your office mute. دكتور احنا ليش بنروح نموف للثانية بعدين نرجع لانه انا بحكي له بلكي نعمل جنب دكتور ابراهيم دكتور would you open the link from your cell phone instead of the computer? دكتور إبراهيم نعمل الجملة الثانية ها؟ تعالوا اقعد محل هون مش سامع من اللي عندي هون شايف هون الصوت لين تعال اسمع هون كيف الصوت هون اوكي بس هون سامع تسمع هون من هون الجنب عندنا هون مش سامعين احنا شيء عشان هيك في زوم اوكي خلاص خلينا نعمل الجملة الثانية عم نحكي له مش سامع ما هو اذا عامل ميوت مش سامعني ما عم نحكي على الفاضي يعني ما في خلينا نعمل شيفت على الثاني اسمع بدي له خلص ظبط هذا ونعمل على الثاني اخر شيء شوف لنا اللي بعدها الهندية Dr. Ibrahim, we had technical problems here. We'll return to you after fixing the problems.
لا لا هي جاهز بس خلينا نشغل الدكتور.
One layer for the input, and maybe single or multiple hidden layer and one output layer. In each layer, we have weight and base. For each input parameter, output factor, and transfer function connecting between these layers. This is the criteria. How do you check your ANN is working perfectly? We monitor the result by checking the R-square, RMSE, and MAE, and MPA, and the correlation coefficient R. This is the result on the left side, TGA curve of the HTP pyrolysis, and on the right show the database used for the ANN, and you can see for each heating rate we have certain data for the training stage and for the simulation stage. This is on the right, the network for the ANN. You can see two input, hidden layer, 10 euro, second hidden layer, 10 euro, and the transfer function for this is tank sink. And the last one, which is output layer, linear function, and we have only one output, weight loss. On the right side, we have protecting, this is the data for the simulation run. You can see the first line, heating rate 5, temperature 733, and the mass left 11.997%. This is the result for the training, validation, and test and all, and you can see how close between the experiment and the protected by the ANN, almost one. This is for the training stage only. Therefore, the second stage will be used for the simulation. This is how do you monitor the ANN work according to the MSC mean square error. And then on the right side, you can see error histogram of training. And you can see is very narrow between minus 0.4, 5 to the 0.23. And you can see the y-axis represent the number of data within this error. And you can see it is for the training blue validation, the green one, and the test for the red one. Then the next step after doing the training, you will go to the simulation. And as we mentioned that we feed 4 different sets for the simulation, and we have this result for the simulation. Again, you have very close with R equal 0.9962. It means the training work for the NN does work properly and efficiently when we feed the data with the new data to the system. This is the error histogram for the 4 data. We have only 4 data for the simulation. And as we mentioned, to conclude from our presentation, efficient ANN was targeting to be developed to protect the thermal behavior of the HTP at heating rate. Weight left of HTP sample were protect as a function of heating and temperature. We try with different ANN structure to get the optimum one by using try and error for the system. As we mentioned, the best architecture, it is 2-10-10-1, 2 input, 10 neural in the first hidden layer, 10 neural in the second hidden layer, and we have only 1 output. And you can see high efficient performance are equal to 1. And then we use for the simulation, and if you check with the new data, we got R.9962. At the end, this proved that ANN model can efficiently protect pyrolysis TGA data for the HTPE and work to be checked for other complex pyrolysis process. With this one, I conclude my presentation, and sorry about what happens, a technical problem. Thank you very much. Thank you.
Thank you, Dr. Ibrahim, for a nice presentation. I will give the floor 1 question, please.
Sure.
If you have 1 question. No questions? Okay. Thank you. Thank you, Dr.
Thank
Ibrahim.
you very much.
Thank you.
Thank you very much. My pleasure. Assalamu alaikum.
Assalam. Dr. Kandu?
Yes. Am I audible?
How are you doing?
Hello?
How are you doing?
Yes.
Are you okay?
It's fine. It's
Okay.
fine. So can I share my screen?
Okay, Dr. Kandu, just let me to introduce yourself to the floor here. Professor Kandu from India. She will talk about the regenerations of CO2-loaded diethyl amino ethanol using organic solvent and waste heat. Dr. Kandu, she is the chemical engineering from University of India. She's worked at the process engineering and Simon Covers Indian unit design consultancy. She is interested in the fluid phase equilibrium and its applications, modeling and simulations. She published 2 books and she published many articles. Dr. Kanadu, the floor is yours, please.
Okay.
And open your camera, please.
Okay. My screen is visible?
Go ahead, please.
Hello?
Yeah, everything is okay. Go ahead, please. Shall we start?
Yes, the screen is visible?
Yeah.
Okay. So myself, Dr. Madhushri Kundu, and I, on behalf of myself and my student, Dr. Subhashish Adat, is presenting the paper on regeneration of CO2 loaded 2-diethyl aminoethanol using organic solvents and waste heat. Actually, our article is having the heart of this presentation is that it is the CO2 rise in the atmosphere and consequential measure for its remedy. Actually, this is a much talked topic.
Doctor, the presentation, where is the presentation, please? Your presentation invisible.
My share, can you see my presentation?
No.
Okay.
It's not.
1 minute.
Would you share it? Would you share it, please?
Actually, I have shared my screen, but
okay.
1 minute. Hello, am I still there?
Just share screen, please, for your presentation.
1 minute. I have shared the screen, but it is. Do you now see the presentation?
Okay.
Yeah,
now it's okay. Thank you.
Okay. If you see, this is the carbon dioxide increase in the atmosphere and consequential measure is a much talked about topic. If you see at these two particular figures, you can just have an idea that the carbon dioxide increment from the pre-industrial era to present time, currently the 412 ppm in the air, the carbon dioxide concentration, and the associated temperature rise is right now is 1.2 degrees centigrade in comparison to the pre-industrial era, that is industrial revolution started from 1765, and now within 2050 we are really apprehending it will be 1.5 degrees centigrade with respect to the pre-industrial era. And the carbon dioxide can be removed, that is CCS, that is carbon dioxide capture and sequestration. My presentation is related to carbon dioxide capture. Sequestration is another paradigm actually. In the carbon dioxide capture, we can use the absorption process, membrane process, cryogenic processes. And for the absorption process, people started with the physical absorption in the Purusol or the Rectisol process, but those processes were not very suitable for the bulk removal of CO2. And it was very energy intensive. And after that came the hot potassium carbonate solution, and then came in a very large way the alkanolamine solutions. Okay, and the very historically started the alkanolamine solution for the carbon dioxide capture from the streams was the TEA, triethanol amine. But after that, monoethanol amine, diethanol amine, all the single alkyl amines and the blended amines already have been used for this removal process, the removal of the carbon dioxide from the natural gas purification, the off gases from the refinery off gases, the thermal power plant flue gases, where we can find a lots of carbon dioxide, and these alkanolamine solutions are regenerative chemical absorption process enhanced by the chemical reaction. And it's a beauty that the solvent is having both the OH and NH2 group. NH2 group or amine group acts as a base, and the OH group reduces the vapor pressure, and because it really involves the hydrogen bonding with the aqueous media, and it increases at the same time the solubility in the water. Okay, so if I see this is a small schematic, that is there is an absorber and it is a dissolver, And the flue gas, actually right now our presentation is related to flue gas carbon dioxide removal. Flue gas is a kind of typical characteristic gas which is having a huge amount of carbon dioxide at atmospheric pressure, and and it is a high temperature at the same time. So it is really I think worthy to mention. And absorber, there is this CO2 rich solvent like alkanolamine solvents etc. are coming, and then flue gas is becoming the sweet gas, and the loaded solvent here, the loaded solvent is here going to the dissolver with the help of the steam at 120 degrees centigrade, almost it is becoming the lean solvent again, and the lean solvent is again used as an absorber. So it is a regenerative chemical absorption process, and there are a lot of chemical reactions that is involved in the liquid phase. Actually, this is a vapor liquid equilibrium problem. In the liquid phase, there are these kind of reactions are going on, that is H2O dissociation, the hydration of carbon dioxide, and the carbamate formation, and the protonation of amine, and the carbonate formation. And the vapor phase, for the time being, we are assuming it is the pure carbon dioxide. So partial pressure of carbon dioxide is equal to total pressure. And if I am going, before I am going passing on to this particular top aspect of my major aspect of my paper, I want to mention this particular thing, that is the thermomolecular mechanism. Actually, what happens here, thermomolecular mechanism is such certain kind of things. Here in this alkanolamine water and the carbon dioxide reaction, you see carbon dioxide, alkanolamine and base may be a water or the alkanolamine. They are coming in the same planar configuration, and their orientation is much, and they react simultaneously at a time at the same place. And that's why this kind of carbamate is formed. And whenever there is a carbamate formation, it's becoming very, very energy intensive to really break out and regenerate this solvent in the regenerator. And that's why this is the bottleneck, that the energy intensive regeneration of the alkanolamines, that is the major concern right now, using the alkanolamine as a suitable solvent for the carbon dioxide removal. But if you use the tertiary alkanolamine, then it goes via the bicarbonate reaction, and this is also happening for the sterically hindered alkanolamine as well. Okay, so that our issue is the energy intensive regeneration of carbon dioxide of the loaded solvent. So our scope right now in the paper, we have put a scope that DEAE, 2-diethyl and aminoethanol, was used as a CO2 absorbent, and pure CO2 was generated using organic solvents and waste heat. Actually, in a very traditional way, we need 120 degrees centigrade steam to regenerate this thing. So it's a huge energy. So that's why a kind of an alternative procedure, alternative process we have proposed. And with this particular thing, also we have really highlighted the thermodynamically predicted enthalpy due to CO2 absorption based on the solubility data. This is also presented over here, so that one can have a prerogative to compare the heat really required for these two processes side by side. And in this regard, people have been working on that lessening or lowering the regeneration energy requirement. And Zhang et al. Actually uses SJD, and they have reported 36.9% less heat duty is required to compare to catalyst-free run. And Wang et al. Also reported 31% heat duty is required when sulfonal is used as a space splitter with MEA for CO2 absorption. And Novak in 2016, actually he proposed that acetone, acetaldehyde, dimethoxymethane, those are the some organic solvents. If it is used with the water, CO2 and the regenerating solvent, okay, these can really lessen the amount of regeneration energy, and this can be done by a low temperature heat, that is the waste heat. And so that's why in this line, actually this paper is actually we have prepared and we have worked in this regard. So before I pass on to that this particular process, I go into that how the solubility data is really very much worthy to model the solubility, to model the heat of reaction. Okay, in that in the liquid phase, there are certain reactions, that is the hydration of carbon dioxide, dissociation of water, bicarbonate, carbamate formation. It is it is sodium bicarbonate formation. Not sodium, it is HCO3 minus formation, bicarbonate and carbonate formation, and it is the protonation of the alkanolamine. And you see that all the reactions have equilibrium constants, and equilibrium constants are activity-based equilibrium constants. And those are available, those equilibrium constants are basically the temperature dependent, and it is available in the open literature. And our group has contributed the protonation of tertiary alkanolamine DEAE in 2017. Okay, we have found out that the protonation constant of this particular DEAE, and along with those KIs, charge balance, amine balance, CO2 balance, Henry's law, etc., are written to find out the CO2 loading, that is moles of CO2 per mole of amine. That is to calculate these things thermodynamically from the thermodynamic model, and we have also experimented previously. Okay, and from that we used the activity coefficient model, that is the celebrated, most celebrated model, that is the Deshmukh-Medal model we use. Actually, in this model, the Debye-Huckel law is used actually, and the non-idealities are considered in the liquid phase. Okay, and there are different long range and short range interactions. There are different long range and short range interactions that is present in the equilibrated liquid phase. Okay, so then we calculated the gammas with the help of I and A, and this is very important. That is the binary interaction parameter. Actually, it is a kind of this kind of form. Binary interaction parameters are functions of temperature, and then how we got it? We regressed all the experimental data and we calculated the alpha I experimental, and we ultimately regressed beta ij as the optimal parameters. Okay, so this is the objective function. We regressed against the experimental data to find out this kind of interaction parameters. Actually, this is very helpful for calculating the enthalpy. Now, enthalpy of reaction for single reactions 1, 2, 3, 4, 5 reactions I have shown. No, so those all the reactions are calculated. The enthalpy of reactions are calculated in this way. And here you see that is the standard reaction of enthalpy, and the excess partial excess molar enthalpy is there. The standard molar enthalpy is actually we are getting from Ki, and excess partial molar enthalpy we are getting from gamma. As we have already told you that gamma is really a function of this. Okay, and we have from the solubility data, from the solubility model already we have found this out. So we can find this thing. And there is another thing, that the enthalpy absorption due to the physical absorption of CO2, and that is the physical delta H for the physical absorption, and this delta H we are calculating for the chemical reaction in the liquid media. Okay, that is aqueous alkanolamine solutions whenever CO2 is coming into it. And this is also this is delta H physical is a function of the Henry's law constant HCO2, and it is gamma CO2. So ultimately, you are finding that overall enthalpy of solution as a summation of delta H physical and as a summation of QI. It is the delta H chemical, and it is divided by NCO. The delta H chemical is divided by NCO2, is the number of moles of CO2 absorbed in the equilibrium. So we can calculate it. So because it is very hard to get every kind of alkanolamine and CO2 the ternary solvent, it is very hard to get the enthalpy data. Okay, so heat of reaction data or overall enthalpy of the solution. So this is a very good way to get this enthalpy data with the help of the model. Okay, the solubility model. So now what we have done here, this is a parity plot. You see, this parity plot is showing that and fortunately we got the DEAE and CO2 H2O for this ternary system, the enthalpy data available in the open literature. So we could get the opportunity to really model and experimental things. We made a parity plot. You see that our parity plot shows that the experimental and model predicted enthalpies are very close to each other, and there are the reaction wise, 5 reaction wise what is the heat of reaction in kilojoule per mole of carbon dioxide that is being plotted. And this is the thing that how this is the this is the algorithm flowchart to calculate the activity coefficient from the model. Okay. So now this is the main thing of our presentation. That is 1 minute. That is, we have done an experimentation that 5 ml of CO2 rich stock solution we have taken of known CO2 loading, and this is of DEAE of known molar concentration. Then we have taken and we have put this in an equilibrium cell, and the temperature was maintained, closely maintained, and then we have added to it 5 mol or 5 ml or 2 ml of acetone and THF, acetone or tetrahydrofuran we have injected in it. And then during the process, equilibrium pressure is rapidly increased due to the release of the
Excuse me, Dr. Kondi, only 2 minutes left, please.
Okay, release of CO2 from the CO2 DEAE solution, and in this process is repeated, and after that 10 minutes this system was started and the CO2 was released, and this process was repeated for 3 times. This process was repeated for 3 times, and this was a control experiment. Control experiment means it is a DEAE water solution. Okay, and that is the loading, that is the CO2 was not there. CO2, it is not a loaded solution. So difference from it, you can see the difference from this giving the CO2. That means at 3 different stages, how much amount of CO2 is released. This is a regeneration of CO2 from CO2 rich 4 mole per liter of DEAE solution of loading 0.9 using acetone at 303.15 Kelvin. And this is the sketch actually. This is initially I saw that there is an absorber and the dissolver unit. Now it is the adsorption and the distillation unit, and a solvent mixture in this between. Here the solvent which is used for the absorption, rich solvent, that is the CO2 rich solvent is coming, and some solvent like tetrahydrofuran and acetone is mixed with it, and here from there it is the CO2 lean solvent, because CO2 is purged. CO2 lean solvent and the regenerated solvent is going over here, and after the distillation, acetone and tetrahydrofuran is gone, and from the distillation unit we are taking with the help of the waste heat, very low temperature heat, we are getting the CO2 lean solvent, and this is again used for the absorption. So this is our modified kind of absorption unit, and here we have shown the things same thing for both the tetrahydrofuran and acetone solvent. Okay, and for acetone we got the 72.85% of CO2 recovery, and for THF we got 38.31% recovery because of complete miscibility with water and interaction between the acetone and amine functional group. Very high percentage of CO2 is released due to the weakening of the hydration shells surrounding the solvated ions. And so, and there are a lot of things to do in this regard, because we have to really experiment on the ratio of the regenerated solvent to be regenerated and the amount of organic solvent to be used and the temperature, etc. That has to be really, again experimented. And people can use it is a kind of dynamic process. People can use in the dynamic simulation with the help of Aspen HYSYS, whatever. And now we are very thankful to our predecessors who have taken a kind of effort to really make an end of the energy intensive regeneration of those loaded solvents. And finally, I want to acknowledge my institute for making the arrangement and support that work. And not the least, but the last, I want to thank the organizers to give me the opportunity to present our work. Thank you so much. Yes.
Thank you very much, Dr. Kondo, for nice presentation. Allowing me to give one question for the floor. Any question, please?
Thank you for your presentation, really. I have a little bit or a small question really regarding the absorption and adsorption mechanism. I didn't see an equation that has the molecular formulas for the adsorbent and the absorbent, how it captures the HCO3 ion. Would you please elaborate on that a little bit? Thank you.
This is you want to say? This particular thing?
Was it there in the presentation? Maybe I missed it, but I didn't see it in the presentation.
Yes, this is there.
It's there?
Yes, it is there.
خلاص, I will go back to the presentation. Thank you.
Okay. Thank you so much. Any question, please?
I guess no more questions. Thank you very much for nice presentation again.
Okay.
Thank you.
Okay. Thank you. You are welcome.
Have a good day.
You too.
Dr. Iman? Dr. Iman?
Do you listen to me?
سمعتنا؟
Yeah. Now I will share my presentation, okay?
Okay. The fourth speaker, Dr. Iman Shakir from Iraq. She'll talk about the groundwater hydrogeochemicals and the quality appraisals for agricultural irrigations in a green belt area in Iraq. Dr. Iman Shakir, she's a PhD student at the Department of the Chemical Technology of Fuel and Industrial Ecology in the Ural Federal from Russia. She was a lecturer at the Environmental Research Center in the University of Technology in Baghdad. She produced about 20 researchers in the different fields of the environmental and wastewater treatment. Dr. Iman, the floor is yours. Would you start, please?
Thank you very much for introducing me. Good day for everyone. My presentation titled The Groundwater Hydrogeochemical and Quality Appraisal for Agricultural Irrigation in a Greenbelt Area in Iraq. This study highlights the groundwater hydrogeochemical characteristic like hydrochemistry characteristic, evaporation, ion exchange, and salinization. Also, the quality suitability assessment for agricultural irrigation purpose for 5 wells in the Greenbelt area, which is located in the northwestern of Al-Najaf governorate, which this governorate situated in southwestern of Iraq. The groundwater suitability for irrigation was assessed based on the Irrigation Water Quality Index for 13 parameters and 10 groundwater quality indices like ECTDS, SAR, and other indices. The objectives of this study are understand the groundwater chemistry, assess groundwater quality, and to determine the suitability of the groundwater usage for irrigation purpose. In this slide, I clarified the site description. At 2006, Iraqi government established a Green Belt project to improve the environment in the area and this project is the one of the most important in Al-Najaf governorate. This project is located in the northwestern of Al-Najaf on the highway between Al-Najaf and Karbala governorates. This site have 8 wells, 3 out of service, and I take the 5 wells as the rest. The assessment method which I used in this study, Irrigation Water Quality Index, and you can see here the classification of the IWQI. And the number 2 irrigation water quality indices, you can see the formula here. And I will clarify in the follow presentation. The result of my study, firstly, hydrochemistry characteristic, we can see the sequence of the abundance for the major cation here for every site. For the major cation, we can see from figure the sodium have the bigger percent for all sites. I think unless to site 4, the bigger here is for the magnesium. Also for the site 5 is the bigger for magnesium. While for the major cation, we can notice for both site 1 and site 2, or for all sites, the sulfate have a bigger concentration. Only in the site 5, the chloride have the bigger percent for the sample groundwater. Desalinization. To assess the salinization level of groundwater in this study, we used Revel index. This is the formula to compute the Revel index. And we can notice from the figure that the Revel index for all sites is more than 0.5. Therefore, the indicate they are all sites affected by high salinization. This is maybe attributed to geogenic activities in the study area, which is caused by anthropogenic input like domestic waste and other things. The irrigation water quality index for the sample, we can notice here for 5 sites. For site 1 and site 2, the samples fall at unsuitable category. Unsuitable category indicate unsafe for irrigation. While the site 3 and site 4, the groundwater sample for IWQI fall at very poor category, and S5, site 5 fall at poor category. That means these 3 sites are useful, are safe for irrigation and possible to use it. The irrigation water quality indices, we use 10 indices like EC, TDS, sodium adsorption ratio, residual sodium carbonate, soluble sodium percent, total hardness, permeability index, potential salinity, Kelly's ratio, and magnesium hazard ratio. In this table, I clarify this equation or formula we used to calculate the indices, and this is the reference which I use it. Also, I clarify the classification of agricultural irrigation from groundwater for every indices here and the range of it. The salinity hazardous is usually measured as electrical conductivity and total dissolved solid. We can notice from this figure the EC more than 3,000 and TDS more than 2,000. That means all the sample in all sites unsuitable for irrigation. And as a result, it's needful to keep the salinity under control while using groundwater for irrigation. The sodium hazard can be measured by sodium adsorption ratio, soluble sodium percentage, and residual sodium carbonate. We can notice all the groundwater sample belong to the excellent category according to the SAR classification. And for the soluble sodium percentage, all sample are placed in the go-to permissible zone. Only the site 2 shows a tendency to shift towards permissible to doubtful zone. Also, the residual sodium carbonate, all collected sample categorized as safe for irrigation purpose in terms of RSC. The total hardness in Site 1 and Site 2 are grouped in the soft water category, while the other site grouped or fall under moderately hard water category. Permeability index for all site, all sample, fall under class 2, the PI between 25 to 75, which consider the groundwater sample were good or moderately suitable for long-term agricultural irrigation with little effect on soil properties. Potential salinity, that's we can notice from this figure, the PS is more than 3, therefore is unsuitable for irrigation in terms of PS, potential salinity. And for Kelly's ratio, we can notice the sample showed KR, Kelly's ratio, more than 1, except one sample for site 4 showed KR is less than 1. And finally, the magnesium hazard ratio, we can notice here all of the groundwater sample were greater than 50 milliequivalent liter, indicate all sample were unsuitable. The conclusion, the very high value of EC and TDS and PS implied that all of sample belong to unsuitable strategy. About 80% of sample with KR content fell in the unsuitable category, except the groundwater from sampling site S4 was suitable for irrigation. The high magnesium higher ratio percent value indicate that all the groundwater sample were unsuitable for irrigation. The samples evaluated based on the index of SAR, SSP, RSC, and PI were suitable for irrigation. That because it depends on the sodium, and the sodium is relative low. Total hardness of sample fell on the soft to moderate soft category for all groundwater sites. And the use of groundwater of the study area as a source of irrigation would impose significant salinity hazards, while the degree of sodium hazard was relatively low. All of the sample fall in the C4, S1 sector according to the salinity and sodium hazard classification. That's due to the long period of residence of water, mineral dissolution from the rock structure, and the intrusion of domestic and industrial wastewater. The finding of this study will be extremely useful for sustainable management of groundwater resources in the study area, as well as allowing a planner and policymaker to devise a strategy to address comparable issue in other area. Thank you very much for your listening.
Thank you very much for nice presentation, Dr. Iman. And I will give the floor one question, please.
Yeah, okay.
Any question? Okay.
Thank you. راحت ولا؟ والله can I?
Do you have any question?
Yes. Thank you for your presentation. Really, my question is the sustainability of underground water. Would you please mention the factors that affect the sustainability of underground water? Because we need to sustain the underground water here in Jordan.
Okay, thank you for your question, Doctor. To sustainability of the groundwater, sure, we must do evaluation for along parameters. Sure, you can know about it. Like for groundwater, especially EC and TDS, this is indexed for salinity. You know, the salinity is very hazard to the soil and plants. Therefore, we must do a control for the salinity and do analysis between a period to know the salinity and the other. You can notice the indices is very important. You can notice it and do it to know is your groundwater sample is okay or not for soil, for plant, or to use it, or maybe you need to do some treatment to be comfortable, to be suitable for a plant. I think this is very important to do between time and time. Thank you.
Thank you, دكتورة. شكرا لك. دكتور الوليد معنا؟
نعم أستاذ العزيز.
اوكي اهلا وسهلا بك.
الله يبارك فيك.
شكرا جزيلا.
Speaker in this session, Dr. Walid Aboud. His presentation entitled Removal of Lead Ions from Simulated Industrial Wastewater by Using Activated Carbon Produced from Heavy Oil Fly Ash. Dr. Walid, he completed a bachelor's degree from the Chemical Engineering in 1993 and finished the master's degree in the Chemical Engineering in 2004. He got the PhD in the Environmental Engineering in 2012. Right now, he's a senior chief engineering in Renewable Energy and Environmental Research Center, Cooperation and Research Industrial Development. Dr. Al-Walid, I'll give you 15 minutes to present your work. Please go ahead.
Thank you, sir. السلام عليكم ورحمة الله وبركاته. نشكر نقابة المهندسين الأردنية، والشكر موصول إلى جلالة الملك والحكومة الأردنية والشعب الأردني على هذه الفرصة في التلاقي مع زملائي. موضوع بحثي هو إزالة أيونات الرصاص من مياه مختبرية محاكاة إلى مياه صناعية باستخدام فحم منشط منتج من الرماد المتطاير الناتج من حرق الوقود في محطات توليد الطاقة الكهربائية. فكرة البحث تنقسم إلى قسمين. القسم الأول هو Solid Waste Management، والقسم الثاني هو إزالة العناصر الثقيلة Removal of Heavy Metals from the Wastewater. فكرة البحث تبدأ أنه تعريفاً للملوثات. هناك كثير من الملوثات اللي تأثر على النظام البيئي وصحة الإنسان، من ضمنها العناصر الثقيلة اللي تعتبر التي تصنف من المخاطر على حياه الانسان، وخصوصا مثل عناصر الكروم، الكادميوم والزرنيخ. ويعتبر الرصاص له خصوصيه خاصه على اعتبار انه يؤثر على النظام العصبي والعظام والكلى عند الانسان، لذلك اختارينا هذا العنصر كونه يصنف من العناصر الخطره. فكره البحث هو الاستفاده من ناتج عرضي ينتج من توليد الطاقه من خلال استخدام النفط الخام، وهذا النفط الخام راح ينتج لنا باي برودكت اللي هو الرماد المطاير. طبعا هذا الرماد المطاير ينتج سنويا ما يقارب 5 طن بالسنه منه، معظمه هو عباره عن كربون من 50 الى 90%، ويكون السايز مالته فاين من 10 الى 120 مايكرومتر، وبالتالي راح يكون هاي الماده تصنف هازاردوس سوليد ويست اذا تركت على سطح الارض او اذا طمرت، لانه تركها على سطح الارض يعني تعرضها للتغيرات الجويه، وطمرها باسلوب غير صحيح يعني وصول الملوثات الى المياه الجوفيه. لذلك كانت الفكره انه هي اداره بيئيه من خلال تحويل هذا الباي برودكت اللي هو الفلاي اش الى فحم منشط من خلال عمليه تنشيط كيميائي وتنشيط حراري. هناك كثير من الدراسات اللي تطرقت الى الاكتيفيتد كربون اللي ينتج من الرماد المتطاير، اللي وصل بها بعض الدراسات الى انه حصلوا على المساحه السطحيه 156 متر مربع لكل غرام، وبعضهم حصل على 144 فارزه 8 متر مربع لكل غرام. فشافوا بانه مساحه سطحيه جيده لاستخدامه كادزوربنت، كماده ممتزه للملوثات في المياه. حتى نحضر هذا الفحم المنشط من هذا الرماد المتطاير، احتاجينا الى انه اولا نتبع اسلوب التنشيط الكيميائي والحراري لهاي الماده اللي عاملناها كرو ماتيريال وعاملناها كويس. يعني احنا هنا العمليه عندنا عمليه اداره بيئيه لنفايات صلبه، ومن نفس الوقت هاي النفايات حولناها الى مواد صديقه للبيئه، ثم استخدمناها في ازاله ملوثات اخرى اللي استخدمناها في ازاله الرصاص من خلال تغيير الكتلة كعامل متغير في عملية الإزالة، وتغيير زمن التلامس حتى نقدر نفحص طبيعة الامتزاز وكفاءة الامتزاز للرصاص. نلاحظ أنه عملية التنشيط تمت باستخدام أكثر من نوع من الحوامض، ومن ثم هناك تنشيط حراري بدرجة 800. يمكن أي سائل يسأل انه لماذا اكثر من حامض؟ لانه نعرف احنا من مخلفات الرماد المتطاير من المحطات توليد الطاقه الكهربائيه يحتوي على كثير من الامبيورتيز، هي الاورجانيك والان اورجانيك، وممكن يحتوي على عناصر ثقيله. لذلك انا هدفي الاول ان انقي هذا الرماد المتطاير من هذه الملوثات، زين، وبعدها احوله الى فحم منشط. وهذه الطريقه تعتبر تقليديه ومعروفه عند كثير من الادبيات، هو التنشيط الكيميائي باستخدام حامض الهيدروكلوريك او حامض النتريك او حامض الفسفوريك، والتنشيط الحراري لاكثر من 600 درجه مئويه، وتحضير النموذج لغرض الامتزاز. التجارب اللي احنا اتبعناها في عمليه الازاله، اعتمدنا على تقييم الامتزاز من خلال معادله الازاله المئويه واحتساب سعه الامتزاز. سعه الامتزاز اللي معادله رقم 2 نعني بها انه ايش قد قابليه هذا الفحم المنشط المنتج من الفلاي اش ان يزيل هذا العنصر اللي هو الرصاص لكل غرام من الفحم. اعتمدنا على موديلين مشهورات في تطبيقات الادسوربشن، هو موديل لانغمير معادله رقم 3 وموديل فرانكش معادله رقم 4، كونها من المعادلات المعروفه جدا. المعادله رقم 3 اللي تمثل معادله لانغمير اللي يوضح لنا انه عمليه امتزاز اي ماده على سطح الادسوربنت، الماده المازه، هي تكون بشكل طبقه واحده. اما معادله رقم 4 فرانكش يوصف لنا الامتزاز بشكل طبقي مالتي لاير على سطح الممتز. استخدمنا موديلات يسموها الموديلات الحركيه اللي هي Adsorption كاينتيك، وموديل المشهورات هو موديل سيدو فيرست اوردر اند سكند اوردر. الغايه من هذه الموديلات هو توصيل في طبيعة الامتزاج مع الزمن حتى نوصف هل هو external or internal or interparticle diffusion، مع توصيف هل انه هو chemical or non chemical، لانه احنا عندنا الفيزيكال، لا اكو الفيزيكال يمكن تعريفه باسلوب عندما نحسب طاقة جيبس. في اول سير تجربه اللي هو تغيير كتلة الفحم المستخدم في الازالة، استخدمنا اوزان مختلفة تتراوح من 0.05 وصعودا الى 0.8 غرام مع 50 مل من المياه المختبرية الملوثة بالرصاص بتركيز 25%، 25 بي بي ام. لاحظنا انه مع زيادة الكتلة تزداد عندي نسبة الازالة، وهذا طبيعي نفسر انه زيادة كتلة الفحم المنشط يعني انا وفرت مناطق امتزاز كافية لازالة الرصاص، فارتفعت عندي الازالة من 40% صعودا الى ان توصل اكثر من 65%. من هاي التجربة نقدر نطلع علاقة ما بين الادزوربشن كاباسيتي اللي هي الكيو اي سعة الامتزاز والتركيز عند التوازن. نقصد بالتركيز عند التوازن انه بعد ما اسوي خلط ما بين الفحم والويست ووتر نوصل الى حد توازن بعد 4 ساعات نضمن انه صار عندي اشباع. نلاحظ انه من خلال الموجود على السلايد امامكم كل ما نزيد الكتلة الفحم المستخدم الادزوربشن كاباسيتي تقل، وهذا جدا طبيعي. ممكن واحد يقول انه ليش الازاله تزيد؟ ليش الادزوربشن كاباسيتي؟ طبعا هاي المعادله من نرجع لها نشوف انه المقام راح يزيد من وزن الماده المازه، وبالتالي سعه الامتزاز. لذلك من فوائد الاكوليبريم ايزوثيرم منحنيات التوازن اللاحراري انه نعرف سعه الامتزاز لاي ادزوربنت، وهذا يشمل طبعا كل انواع الادزوربنت ان كان فحم منشط او ايونيك اكسشينج او السيليكا جول. من خلال هاي النتائج اللي حصلنا عليها طبقنا النتائج اللي حصلناها من علاقه الادزوربشن كاباسيتي مع التركيز عند التوازن. نلاحظ انه اني حصلت على تقارب جيد مع موديل فرانليش مع مربع معامل الخطا 0.971، وهذا معناه يدل على انه افضليه تطبيق هذا الموديل اللي يشير الى انه عمليه الامتزاز الرصاص على الفحم المحضر من الرماد المتطاير هو عباره عن مالتي لاير، ودليل على انه هناك هوموجينيتي للسطح اللي احنا حضرنا به الفحم المنشط. عندما اتجهنا الى الوقت، تجربة الوقت اللي قلنا الغرض من عندها انه نعرف طبيعة الامتزاز مالتي هل هو external or internal او interparticle. هو الغرض
تفضل دكتور محمد، دكتور وليد.
الارتباط مع موديل سيدو سكند اوردر افضل من فيرست اوردر، ومع انه حصلت على كيو تي اتش اللي نشير لها الى adsorption capacity theoretical، لانه انا عندي adsorption capacity experimental حصلتها من العمل، والثيوريتيكال انا بالاكسبيرمنتال حصلت 2.25، بينما نلاحظ هنا بالسكند اوردر كاينتيك انا حصلت 2.75، معناها التقارب افضل من فيرست اوردر. هذا يدل لي على انه الامتزاز هو كيموزوربشن، وانه الامتزاز صار اني عندي انترنال. بالنسبه لهاي الحاله امتزاز الرصاص على الفحم المنشط المحضر من الرماد المتطاير. نلاحظ الكيرف كيف انه اني حصلت على ارتباط افضل من موديل سكند اوردر من الفيرست اوردر. نستنتج من هذا العمل انه احنا ممكن ان نحصل على فحم منشط من مخلفات صلبه من عمليات انتاجيه، وبالتالي انا سويت عمليه تخليص البيئه من اي ملوث، واستخدمت هذا الماده اللي حصلت عليها اللي هو الفحم المنشط لاستخدامات اخرى لمعالجه ملوثات اخرى. اسف. من خلال النتائج اللي حصلنا عليها شفنا انه الموديلات اللي تنطبق على ازاله الرصاص باستخدام هذا الفحم المنشط المحضر من الرمان المطاير هو مع موديل فرانفيش اللي هو يدل على انه هناك عمليه امتزاز مالتي لاير تصير، ولانه سطح وليس اون وانما نون هيتروجينيوس ادزوربنت سيرفيس. فيما يخص الكاينتيك ستدي اللي هو احنا نغير بها الزمن، لاحظنا انه تطابق موديل سيدو سكند اوردر مع عمليه الازاله يشير الى انه انا عندي العمليه كيموزوربشن، وان انا حصلت على ثيوريتيكال ادزوربشن كاباسيتي 2.27 اللي هي تقارب للاكسبيرمنتال اللي هي 2.25. شكرا لاستماعكم، والشكر موصول الى الجهه المنظمه، ونتفضل باي سؤال لاي زميل من الزملاء.
شكرا دكتور وليد على هذه المحاضرة المهمة والقيمة، ونفتح باب الأسئلة إلى الأخوة الحضور. في سؤال أو سؤالين سمعت.
شكرا دكتور وليد على هذه المحاضرة القيمة. بس عندي سؤال حقيقة، هو لماذا لم تستخدم اويل اش دايركتلي از ادزوربنت بدل ما تحوله لاكتيفيت كربون؟ هو ممكن تستخدمه دايركت، ممكن تسوي له كمان تريتمنت باي كيميكالز اور اسيد بدل ما تحوله لاكتيفيت كربون وتخسر انرجي وكيميكالز. وايضا اعتقد انه كمان الادزوربشن كاباسيتي بالنسبه للاكتيفيت كربون not too much and also surface area quite low. Thank you.
نعم استاذ العزيز، بس اتشرف باسم حضرتك.
الدكتور عبد الباري البوراني. الدكتور عبد الباري عبد الرحمن.
الدكتور عبد الباري اتشرف بحضرتك. احنا بدنا نتعامل مع نفط خام، والنفط الخام طبيعي بعناصر ثقيله لانه هو يكون تحت الارض. ان استعملت الفلاي اش وكانه اني اضفت ملوث الى ملوث، لانه اصلا هذا الرماد راح يكون يحتوي على كثير من العناصر الثقيله، الرصاص والفاناديوم. فكانت الغايه مالتي من هاي عمليه الموديفيكيشن ان انقي هاي الماده من الملوثات. مع شغله اخرى وانت استاذي اكيد تعرف بيها، هو السيرفيس اريا. انا ما اظن انه السيرفيس اريا للفلاي اش جيده راح تكون مثل السيرفيس اريا بعد عمليه التنشير. هي الغايه من التنشير شنو؟ يعمل عمليا، عمل انه التخلص من الامبيورتيز اللي هي الشوائب، وبنفس الوقت يزيد لي المساحه السطحيه. فارجو انه وضحت هاي لحضرتك واتشرف بك.
في أي سؤال آخر من الأخوة الحضور؟ إذا مرة أخرى نشكرك دكتور وليد على هذه المحاضرة.
أشكر باسمكم زين زميلتي مهندسة فاتن اللي ساعدتني وهي وصلت لي أنه أشارك بهذا المؤتمر، والشكر لجميع الحضور ونخص بها نقابة المهندسين الأردنية.
شكرا لك مرة ثانية، واسمحوا لي أن أشكركم جميعا على حضور هذه الجلسة. والآن في بريك كافي بريك بليز إذا حابين. يعطيكم العافية.